next time I think we can have a physical training program exclusively for millet and sorghum scientist. Maybe whenever we have a field day, so along with that field day, we'll have physical program, and we are thinking of providing a 2-person 1 computer, so that you can have online analysis and everything. So that is what I'm planning it. Maybe I'll get it approved from the director, and maybe the next field day we can have that physical program if everything goes normal.
Good afternoon, sir.
Prabhuji, good afternoon.
Good afternoon.
Sir, we have reached 45 plus.
Yeah, let us go to 7. Those the digital field book planning, we are planning to add to tomorrow by 11 to 12:30, in addition to the regular program. And those who want to join may please say yes in the chat box. Okay, we are getting delayed. I think we can. Dear, we have 3 lectures. One on Geospatial Technologies in by Dr. P.D. Sri, is a principal scientist. Now he has in geospatial and also R analysis and so on. And after that, we will be having the same GIS technique, how to use that software Diva, how to make biodiversity mapping, diversity, or how to analyze the diversity and the richness using the Diva GIS tool that I'll be taking. Followed by, we'll be having Excel. This is a tool for database making. So that also. So today we have 3, and the first lecture.
We are not hearing, sir.
Hello.
Yeah, disconnected, sir. Amsida? Ganapati, sir? Maybe all from IIMR they have disconnected.
ಗಣಪತಿ ಸರ್ ಫೋನ್ ಮಾಡಿ ಕೇಳಿ ಏನ್ ನಡೀತಿದೆ ಅಂತ ಮಾಡ್ಬೇಕಾ ಲಾಗೌಟ್ ಆಗ್ಬಿಟ್ಟಿದೆ ಅಲ್ಲಿ. ನೋ ಇಂಟರ್ನೆಟ್. ನೀನ್ ಜಾಯ್ನ್ ಆಗಿದೀಯಾ? ಎಲ್ಲಾರ್ದು ಹೋಯ್ತಾ ಅನ್ಸುತ್ತೆ. ಬಂತು ಇಂಟರ್ನೆಟ್ ಬಂತು.
एक मिनिट आणि
Sorry for the interruption.
Yeah, Dr. Venkatesh, are you there? Dr. Venkatesh?
Yes, sir. Yes, sir.
Think. Let us start our session. Sir, I request Dr. Venkatesh to kindly introduce the speaker. So there was some internet issue, sir. Now we have fixed it.
Thank you, sir. It's my privilege to introduce the today's speaker, that is Dr. P.D. Srikanth. Yeah, so sorry. So Dr. P.D. Srikanth is principal scientist at ICAR NARM, principal scientist computer applications in agriculture. His areas of research include big data analysis, geographical information system, remote sensing, soft computing tools. That includes artificial neural networks, fuzzy logic, support vector machine, etc., and also computer applications. So he has published more than 40 research papers and also many other articles such as books, chapters, and copyrights. So his major contributions in research includes applications of GIS technology in watershed management, crop mapping, and many other applications in agriculture. So I am thankful to the organizers for giving me opportunity to introduce the speaker. Thank you.
Thank you very much. Shall I start now?
Yes, sir. Yes.
Okay, let me share my slides. My slides are visible?
Yes, sir.
Okay. Okay, we will start this. In this session, we will discuss about geospatial technologies, especially in agriculture, what type of technologies we can develop in this agriculture. So to develop a geospatial technologies, here we are using a different type of data. Not ordinary data. The data, whatever data we are using in this for developing this technology, that is a spatial data. The difference between ordinary data and spatial data is, suppose if you see on your left side screen, if you see there is some just assume this is a plane and you want to identify this particular point on a plane where exactly it will fall. So in this case, you need a x-axis and y-axis. Once if you know the x-axis and y-axis, the intersection of that particular point, you can identify where exactly it locates on a particular on that plane. So this is deal about the coordinate system, but here we are talking about spatial data. Spatial data means the data, it is a information, it is a information about a particular spatial feature, and this information will be in the form of numerical values, and these values will come from geographical coordinate system. Why I'm explaining about coordinate system means In school days itself, we might be aware about the coordinate system. By using the coordinate system, we can identify a particular point where exactly it will fall on a plane. That is nothing but a 2D. Coming to the spatial data, here we are talking about geographic coordinate system. Geographic coordinate system, nothing but exactly, it is nothing but a 3D visualization and exactly where it will fall on our globe or Earth. That is what we are discussing. So that type of data we are going to use in these technologies. And with these, what we can do is see what is happened, what is happening, and what will happen. The past, present, and future, we can visualize it, we can see it. So based on the historical data, we can present how what is happening and how it will be in the future also, we can predict it. So these trends, all past, present, and future trends, we can extract it and we can visualize the things. That is the beauty of this platform. And by using this one, we can develop applications like you can see here some of the areas I am showing here. The GA is medical side, advertisement side, insurance side, government needs, environmental management. So where not, everywhere you can apply these technologies. So these technologies, you can apply it from art to science, anywhere you can fit it, these applications. It is a multidisciplinary, anywhere you can fit it, this type of analysis tools. And especially in agriculture, if you see, we can develop like a mapping, urban planning, transportation planning, hotspot analysis, environmental impact analysis, irrigation water management, so many. This is a few applications. So many we can develop it in especially in agriculture. And coming to the data analysis portion, if you see the past, how the data, spatial data importance, it is around some 2 decades back, I'm talking. What is the spatial data importance in our data analysis? And present, what is the scenario? You can see the scenario is completely reversed. We are realized the importance of spatial data and we are giving the more importance for spatial analysis. So even if you want any publication, if you want to publish any papers, particularly they're asking the result should be in the form of Gis Map. Like that, people are specifically, they're asking the spatial data in the form of maps. So that is the importance of this platform. And now we realized this. And now you see here, it indicates, if you see last 2 decades only, the research paper, the research in this area, how it is increasing. Here I mentioned research articles in the area of GIS and remote sensing. With these 2 keywords, just I identified some of this is only few, part of the data. So with a few keywords, we can see almost the last 2 decades data. If we observe, almost all 7-fold of increase you can see here in a research area, in the form of research publications. So that is what I mean, that people are recognized the importance of the geospatial technology, and now we are concentrating on one. You may ask whether it is a very new technology like that. It is a very old technology. You can see he is the father of GIS, Roger Tomlinson. When he was, in 1969 itself, he developed a system called CGIS, Canada Geographical Information System. That is for Canada Forestry Department purpose. So those days itself, people started using in 1968 itself. And 70s, 80s, there is no much applications and all. 90s, why the gap? People are not recognized this technology, means reasons may be so many. The hardware, software cause. So those things we are not discussing here. Again, if you see 90 onward, slowly the technology is improving. So this is not only, it is not a very new technology. Even 1854, if you see, Dr. John Snow, there was a severe cholera outbreak was there in London during 1857. So people were thinking it was spreading through air and light. So what he did, by using the cartography technique, he did some analysis and find out that it is because of water contamination. Somewhere the drinking pipelines, water contamination, the cholera was spreading like that. So even 1854 itself, people started using the analysis with the help of cartography. Now the thing is, only the hardware and software is new softwares we are using. The interface change, the methodology or concept is very old concept. Okay, even now you see the very popular companies like IBM and Hexagon, huge amount they are investing in this area. for developing a agriculture application with the help of geospatial data. So the IBM, the core IT companies, now they are, huge amount they are investing and they are developing, because they know the platform, wherever they are leading, the platform is almost all saturated. Now this is the next era is with GAs and with the help of GAs only, we can develop very good application. That is why even Hexagon, this is one of the IT company once again. Now they are involved, a huge amount projects, many projects are there, their projects, and they're developing applications. Not only these two, very popularly we know these Microsoft people. These Microsoft people also, they are, crores of rupees they are investing and developing the geospatial technologies, especially for agriculture field. So that is the thing. Now people are realized the importance of these technologies. And another one is a Google Earth Engine. This is one of the very good open source platform, and huge terabytes of data. You will get it freely, free of cost. And many of the images are free processed images. You will get it here with the different resolutions from 1985 onwards, with the different resolutions from 1 kilometer to up to 10-meter resolution. Sentinel today you are getting 10-meter resolution images. So the processed images you will get it from this platform and directly. And already the ready-made libraries are available in this on this platform. You can here it will support Python and Java scripting, even though we don't need to bother about the coding and all. Already the ready-made libraries are available. Just drag and drop, you can use it, and with a slight customization you can go for analysis. So this is the one of the platform. Why I'm showing this one means our recent concluded project we did on this platform. I will show you some of the results by using the Google Earth Engine platform. Okay, and coming to our topic, these are all I don't need to tell all these revolutions before and after independence. Once upon a time, we were with a begging bowl in front of developed countries for food grains. Today, this is our status. So world third largest economy after US and China. So we are large producer in many like wheat, rice, so many things. We don't need. So the thing is, this technology is sufficient for our future, because by 2050, what FAO is predicting, our world population will be 9.1 billion by 2050. So to feed this population, we have to produce 70% extra production. What we are producing today, 70% extra we have to produce. Is it possible? That we have to think it. And in front of the challenges, if you see, these are all the challenges. The fertile lands are converting in some other form. The real estates are some other way. And mainly climate change. And another thing is, the farming community, next generation farming community, they are not showing much interest to continue in this field, because they are attracting towards cities and also with these challenges, how we will produce 70% extra in for our future generation. Our natural resources are shrinking. So this is the condition. And another thing is, if you see, we are in large producer in all so many, including rice, wheat, milk, all these things. But another side, if you see malnutrition list also in India, it appeared in malnutrition list also. So the thing is, one side we are producing more production, and another side we are in malnutrition. This is because of lack of agribusiness activities. Because that is what these type of questions we can answer with the help of these geospatial technologies. Okay, and here you can see some of the major soil types on Earth, on our globe. Out of these, half of the soils you can find it in our India itself. That is the beauty of our country. More than half of the soils, on globe soils we can find in India itself. And we are having different agroclimatic zone and ecological zone. Why I'm showing all these things means, whatever the recommendations will come at the district level or mandal level, the blanket recommendation, it won't work at the cadastral level, because our Indian agriculture is highly location specific. So we need site specific management. So every meter, every feet, the values drastically it will change. In that case, the blanket recommendation, it won't, it won't applicable, it won't recommend, we cannot recommend those type of cultivation practices and all. So we need a site specific management. Site specific management, nothing but it is a precision agriculture once again. So we no need to apply the input the entire field wherever required. So the system will suggest you where exactly the inputs are required, how much quantity it is required. These things easily you can analyze and you can go it. So in this way, we can save the farmers' income also. The inputs cost, we can reduce it. It is one way saving the farmers' income, and another side environment. We are saving the out of pollution also. We are saving environment also. In this case, one small exercise, just one screenshot I will show you. This is the NAM campus. Here you can see one of the experimental, one of the plot I had taken here. This is around a very small area. This is 0.04 square kilometers. And we collected some soil samples around the plot. And these are all the values, soil analysis values. Now, what I want to tell, just you take it pH and potassium, just these analysis, how in the soil, how the pH will appears and K values will appear. That we can do the analysis like here you see, this is the values after soil test from soil lab, I will get it like in the form of CSV or Excel file. Those values we can put it on the GIS platform and we can do the analysis. See now, it will provide finally the analysis, it will give you this is the pH values. Now based on your soil data, now you can see the entire plot, what is your pH availability in that plot. Now you can decide where the pH is very less, where pH is moderate and where pH is very less. Based on that, you can recommend it where exactly the inputs are required. So these type of analysis, it will be very much useful, especially for farmers to save the inputs and input cost. Okay. At the same time, again, potassium, if you see, actually the potassium from lab, we will get it the values like ppm values. So those values we have to convert into kg per hectare. Then only the potassium oxide, how much we can apply on a field, that we can do it. So this is you may be knowing all these things, how to convert from ppm to kg per hectare, then again potassium oxide for kg per hectare and all. So these analysis we can include in spatial data and we can go for applying of that particular fertilizers and all. See, after the analysis, you will get the results like this. This is the raster image. Once if you convert this one into, I will tell you what is raster and vector. Once after converting, you will get the output like this. So finally, if we see that only the small portion of field analysis for only potassium and pH values analysis, you will get it final results like this. How handy now it is, the results are, you see, where exactly the inputs are required, how much it is required, and where it is excess. It is, inputs are not required. Those areas easily you can identify, according that you can go ahead with your plans. So this is one of the example of how we can use these geospatial technologies. And another is generally the farming community, what they're expecting from research community means mainly they are seeking answers from all these questions from the research community. How to grow, what to grow, when to grow. This is the major problem in farming community. They don't know actually what crop they have to grow. Presently, simply the neighbor, whatever is growing, same crop he is also planning for growing. All these things without scientific knowledge is doing everything. But today, almost all farmers, they are using Android phones. If you give a single click after standing in his field, the information should come. What is his soil type? What is the weather condition in that area? Which crops are suitable and what type of cultivation practices he can go for it? All this type of information it should come. And after that, after harvest, that is the main problem will start. After harvest, whether the market prices are there or not. If there is no market price, where is the nearby godowns or cold storages where he can store his produce, and how many surrounding markets are there? These type of information, already information we have. but it is not on a single platform and it is not reaching to the farmer. So these type of, we can answer for all these questions with the help of these technologies. Okay, so we can develop a very good spatial decision support systems with all data mining tools, that latest data mining tools like whatever you are seeing now, from artificial intelligence to different, now people are talking about big data analysis. Everywhere we are talking about big data analysis, because we are generating a huge data we are generating, and we are unable to handle the data. So that thing, now the big data concept, it has come to handle and to analyze. So these type of latest technologies also we can incorporate in our geospatial analysis. That is what these slides told. And here, to develop this spatial decision support system, we need different type of data sets at different scales for developing a decision support system at a national level, regional level, or sub-regional level. So whatever decision you are taking at a cadastral level, the same data set you cannot use at mandal level or district level. And again, same, the whatever resolution you are using, according that the data sets should be changed. So for this, we have to develop different data sets for developing the spatial decision support system. Okay, and this is internet information only. You can see the data agricultural databases having in a different different organizations are on different platforms. The agriculture research information, almost all 200 TB data we are having, maybe more than that. This is just browsed from one of the site. And this is the biotechnology information, almost all 300 terabyte. Like this, each department is having a huge data, but this data is not on a single platform. That is the unfortunate thing in our country. We are unable to develop a very good application for utilizing all these data types. And here you see the data may be in different types. Some data may be in a numeric format, some are in text format, some are in images format, because data are generating different organizations, it is coming from different sources. And some data are daily, seasonal, annual data will be there. And some data, structured data will be there, unstructured data. So these databases all should be, we have to maintain at a unique, on a unique platform. You have to maintain at all these structured, unstructured, small data, big data. So it should be a uniformity. So these things, it will take care by database management system. That is why the geospatial technology, it is a combination of mainly three fields. One is database management system, another is cartography, another is statistical analysis. The major top subjects are involved in this is database management system, cartography, and another is statistical analysis. With the help of these, we are doing the analysis for multi area and different areas also. So here you see, this is the era of data usage. Just if you assume last 1.5 decade back, what is our data usage and present, and just you take our system itself. Our system, if you see last 1.5 decade back, we were using hardly 156 or 252 RAM. Okay, that is memory RAM speed, and hard disk hardly 1 GB. And internet processing speed, if you see, 10 kbps those days. Now presently, the minimum configuration is the 8 GB RAM we are using, and the hard disk space minimum, the 1 terabyte we are using, and the processing speed, if you see, 100 Mbps. Where is 10 kbps and 100 Mbps? You see the technology developed within span of just 10 to 15 years. Why it happened like this means we are generating a huge data. The real-time data, continuous data we are generating through remote sensing, through sensors, various different ways we are generating the data, and we are unable to handle those data. That is why the big data platform, it will handle and it will do the analysis. Now you see just the prediction of the data generation by 2025, we are estimating around 175 GB. Now the kilobyte, megabyte, terabyte, all are gone. Now zettabyte we are using. The zettabyte units, if you see, 1 zettabyte approximately this many kilobytes. 1 kilobyte is 1024 bytes. So if you see, if you take it 1,000 average, this many zettabytes data we are generating every year. Huge data we are generating. That is what the big data here, just one slide, just I want to show you whatever this is the actually the big data platform, how the data will be analyzed, whatever softwares you are seeing on the platform, these are all the open source softwares. So the complete the big data analysis you can develop with the help of open source softwares. That is the beauty of the entire topic here. We are talking only open source data and open source softwares only. So this is the one plus point. So the latest technologies like big data analysis also we can perform with the help of open source softwares. Okay, and with the help of big data and geospatial technologies, some of the very excellent applications you can see it. Walmart, John Deere, and Monsanto. These are all just one few applications I mentioned here. Very successful applications, online. Real-time applications. N number of applications are there. And unfortunate thing is we don't have any big data analysis application for farmers in geospatial technology, because we don't have a data, the whatever required data, the entire in the previous slide, whatever I showed, those data we don't have on a single platform. That is the problem. So we cannot analyze whatever data we want. If suppose if I want a weather data, means I have to approach so and so organization, so much procedure will be there. So after that, so many, these are all the, you leave it, the procedure, how we are going to get. Once if you put it all data on a single platform, we can go for this type of very good applications, and it will be very much useful. So why I am showing this one means the latest data mining tools also you can merge with the geospatial technology, and you can go for spatial analysis. Okay. And here you can see the spatial technology, the geospatial technology, mainly it is a combination of all these three majorly. The remote sensing, GPS, and yes.
इसके 3 mandates में teaching, research और extension.
Somebody. Okay, so it is mainly, it is a combination of all these three fields. And coming to the remote sensing, very briefly I will explain it. What is remote sensing in layman as a layman definition? If we see what is the remote sensing means, it is without physical contact we are accessing the information from far away. Okay, so after getting the remote sensing images, the data how it will be, it may be, so we are not going in depth how the data will store or how the format and all. It will be in the form of, depends on the aircraft or spacecraft, depends on the manufacturing. It will be different bands will be there, the data will be stored. So the data how it will store means mainly the data will be occupied as a grid or pixel. Whatever screen you are seeing on the monitor, there are different colors. How these colors are coming means each pixel will hold some value. So the value represent that color. So that value, how it will come means, if you see our basic colors, red, blue, green, those colors are basic colors. And you may be, just let me explain with the help of some software. Okay, we are familiar, if you take it any software, like Word, Excel, or this is a Paint, you may be familiar. If you open the color, generally we won't observe very keenly on color pattern. Generally here you can see, the basic colors you can, here you can see red, blue, green. It the values, how many values means it will actually, it is if all values are 0 means just a minute. See, if all values are 0 means it is a black, and all values are white means the value you can see it is a 255. It is a 2. So each color will represent 256 shades. Each color, red it will represent 256, blue and green. And again, any color if you take it is a combination of all these three. So remote sensing, what it will do, remote sensing analysis, it is a simple, as a general definition I'm telling. Each pixel will hold the combination of all these three colors. How many shades it will generate means simply you factorize it. R0 for one shade, R0 if you take it, G255 factorial and blue 255 factorial. Just you assume how many combinations it will come. Same way again R1, R2, like that R255 it will go. This way n number of colors you will get it from this color pattern. So each pixel will hold some value. That is what I want to tell here. And the remote sensing images, it will hold some values. The values we have to identify, it will represent what? Suppose if I want to identify how much area under groundnut or how much area under rice. So these things, first you have to take the spatial signatures of that particular crop or whatever it be. And the spatial signatures are nothing but is reflection values. The reflectance values, once if you know my groundnut value is so-and-so value, then you assign to the system. This is suppose, for example, 145 is my groundnut reflectance value. This is the value. So you collect some ground controlling points and give it to the system at the time of analysis. So this is the groundnut value. And in this picture, how much groundnut crop is there under area covered by groundnut. So system, what it will do, based on the pixel value, it will identify how many pixels it is holding same value, and it will give you these are all the pixels having same value. Then we can decide it, the groundnut is under this much area. This way, whatever crop you want, you can analyze and you can do it. So this is very briefly about remote sensing. This type of analysis we are doing generally wherever the area is large, like natural disasters like cyclone, drought analysis, these type of things. We can use it with the help of remote sensing analysis, where it is very difficult to collect the data. And coming to the GPS, global positioning system, it will give you the accurate lat land positions, and these things, it will helpful for developing a precision agriculture. And coming to the GIS, it is a platform for developing applications. It is nothing but a combination of hardware and software. Okay, with the help of these two, one source of inputs. With the help of these input data, we can go for analysis. Okay, this is very brief about geospatial technologies. And coming to the structure of this GIS, here you can see one front-end tool will be there. Whatever software you want, you can use it in the market. So many commercial and open source softwares, n number of softwares are there. Okay, and again, coming to this back-end tool, here any software you take it, only one type of database we are using. But here we are using two type of database. One is spatial database, another is attribute database. This is the beauty of this structure. Here you see the spatial database, what type of data we are storing in this means, it stores the absolute or relative location of a particular spatial feature. The spatial feature where, an Earth or globe, whatever spatial feature, the exactly absolute or relative location, it will store in the spatial data. And coming to the attribute data, generally this attribute data, it gives the information about a characteristics of that particular spatial feature. Okay, and any software, if you take it, this spatial database is a built-in. You can store all your spatial data in software itself. And if your attribute data is very small, database means you can store it there itself. And otherwise, generally, the attribute database is a huge data, and the continuous updates will be there generally for attribute data. So we will maintain as a external database, and we will link it to the spatial data, and we will do the analysis. Suppose one simple example I will give you. Suppose I want to work with the Aadhaar database. So for collecting from Aadhaar server, if I collect the entire information of India, it is highly difficult to store in my server or in my system. I need one more supercomputer. So instead of that, why can't we take access from that server, and that we can link to our spatial data, and we can go for analysis. That is the other database connectivities. It will help you how to connect. Here, the database management will plays very important role. How we are designing your database, how we are establishing your relations, and the external data, how we are linking. This is the database management system. It will deals. And another thing is coming with the help of maps. That is what cartography we are going for analysis. This is very brief structure of this GIS. And coming to the types of this GIS, just now we discussed about it as two type of databases. Now we will discuss about spatial data. Spatial data divided into two types. One is raster model. Raster model, nothing but our remote sensing data. The data will be stored in the form of grids or pixels. Okay. And another is vector model. The data will be captured in the form of either points or line or polygons. Whatever spatial feature, the data we are going to capture either as a point or a line or polygon. This is the way the data we are going to store, or we are going to capture the real world data we are capturing and putting either in our vector model or raster model. Whatever way we are keeping the data is same only. It won't change. Suppose if it is a raster data and vector data, doesn't matter. We can convert, after that we can convert it. Suppose some organizations, they are generating a raster formats. Some organizations, they will generate vector format. Depends on their, from where we are getting data and what type of format we are getting. During our analysis, there is a compatibility. We can convert into vector to raster and raster to vector. That time the data it won't change also. For example, if we take our Word file, the extension is .docx, the latest version. If you convert into PDF, the data, it won't change. Only the format will change from docx to .pdf. So the data, it won't change. Same way, if your data is in vector model or raster model, doesn't matter. The data, it won't change. Only format make different. That's all. Okay. And coming to the maps also, it is not a new technology. The putting the information in the form of maps. It is a very old technology. Even if you see in Stone Age itself, people started carving on stones and all. Then hand-drawn maps, then printed maps and digital maps. Now this is the era of GIS maps. If you see the difference between these two maps, the digital map and the GIS map, you can observe one major difference. That is, here you can see in digital map, the entire data, whatever data you are seeing, just assume that there is a all lake information or polygon information, whatever, if you want area or whatever information, and network information and urbanization information, all information is in a single file. Okay. But coming to the GIS, how we are going to store in the GIS, the data will be in the form of layers. Okay. So each layer will hold only one spatial feature. It won't hold more than one. So the data we are going to capture in a layer format, and each layer will hold only one spatial feature. This is very important. And this is the way. The bottom layer is just, you assume that is our real world. If you want to extract the vegetation from that your study area, the vegetation, you can make it as a one layer, and the urban area, if you want to make it as a separate layer, and suppose the canal network or road network, whatever it be, if you want to make it as a data, means you want to extract it, means you can maintain as a separate layer. This way, the data will be bring out in a different layers in this format. Okay. After generating the layers, each layer will be attached to one attribute table. That is what we discussed about spatial data and attribute data. So whatever layers we are generating here, this is a spatial data. And whatever attribute data, the characteristics of that particular spatial feature, the spatial characteristics of that spatial feature, we are attaching to the layer, and we are establishing a relation, and we are extracting the information. Okay. This is what we are doing in this analysis. And after that, see, I told you each layer will hold only one spatial feature. That is why in GIS, if you see the in this database, n number of layers will be there for a particular area information. So that layer here, by using the overlay techniques, we can overlay it and we can go for analysis. Generally, any system, if you take it, at least minimum 150 layers overlay analysis, it will support you. There is no limit at all. Depends on our system configuration, it will support you. But generally, our complicated data, any complicated data, if we take it, the overlay analysis hardly 10 to 15 or hardly 20 overlay analysis only we are doing. But system will support minimum 150 overlay analysis. Again, depends on your system configuration. So here, just 2 layers overlay analysis, how it will be. Just assume this is a soil layer and this is the crop layer. Okay, if you analyze it, the result will be like this. The crop, same crop, the A crop, we are growing in 2 types of soils. Now, as a subject experts, you can analyze it. What is the productive? What is the yield in soil 1 and what is the yield in soil 2? And based on your subject expertise, you can do some analysis why it is varying and what is the problem. How you can improve it. All these things you can think it out. And here the overlay, nothing but what we are doing, all layers we are stacking one and above, and we are drilling wherever our area of interest, there only just you drill it and extract it, all information from bottom to top layers. Okay, we are not doing the analysis for entire area. Suppose I want to do the analysis for entire Telangana, I don't want to do the entire India. Only Tamil Nadu, you take it the layers of entire India and do it analysis only for that particular your study area, that is Telangana. That way you can do it with the help of overlay analysis. Just we are like a drilling, just we are drilling on that particular area of interest and extracting the entire information from bottom to top. Okay, that, and in this condition, while doing the analysis, these things very important. We have to very careful about the projection and the scales. The both projection and scale should be same at the time of overlay. Okay, and one simple example, let me give the GIS images, how it looks. The GIS here you can see 3 images decade wise, 81, 91, 2001. If you see the images, the trend, how it is changing every decade. It is a data of female literacy rate, how it is changing the growth rate, you can observe it. This is just raw data, district wise raw data. So same data, if you put it in the form of Excel or some other format, it is highly difficult to identify this trend and all. Same data, if you put it in the form of GIS maps, the raw data itself, you can identify the trends before analysis itself. That is what I want to tell here. And another thing is, here you see, this is a latest one of the publication, solar power in India. It is around 280 pages publication, and it holds all this type of tables and bar graphs, all these things. So it will take time to analyze it. I mean, to understand the thing, entire thing. Instead of this, if you put out 2 images, if you see the GIS 2 images, more than 60-70% information, it will explain you what is the power generation, solar power generation in India, how much it is, and what are all the major stations. So like this, it will give you a bird eye view on your data, raw data itself. It will give you a bird eye view, and the raw data itself, you can see the patterns, how it is changing. And another thing here, you can see the data. It is oil palm data, 4 columns you can see here state-wise. And first one is a potential area and how much area they covered. Potential production, how much production they are getting. Okay, if you see this, this is a very small database, hardly some 20-25 records. So to understand which state is performing good, we need some time to understand the data. But the same data, if you put it in the form of GIS maps, how easy it is. See, it is a ready reckoner to, I mean, the first top image, it will show you what is the potential area in that state and how much area they are utilizing. And what is the production downside image, it will indicate how much what is the potential production there and how much production they are getting. How clearly the info, I mean, this is the only raw data. Whatever left side you are seeing, same information in the form of GIS only we are showing here. And see some of the, I mean, this is again our students data, PGDMA students data. Just for example purpose, I taken here. Here you can see some S-Bank locations are there. Dealers information is there. Okay. Now, one of the activities, the dealer has to report nearest the S-Bank location. In this case, if you put it the data will we can visualize it like this. And now we can go which is the nearest branch to report that particular dealer. This is what I mean, that bank people need the nearest bank they have to report. In this case, we can go for analysis like this by using distance matrix analysis. We can analyze and we can see what is the distance from each point to that particular point, how many kilometers it is, and whatever analysis we are doing here, this is the aerial view analysis. I mean, from point to that particular hub, direct through aerial view, we are doing the analysis and we are calculating the distance. If you want on ground exactly what is the distance based on your road network, then you need another data like road networks. Once if you get it the road network, you can do the analysis. And presently the Ola and Uber, how they are working means based on this analysis only. So where is your starting point, where is your ending point? Based on that, automatically it will calculate it, which is the shortest path or which is the fastest path. According that, it will calculate it. Presently, the apps, the market, I mean, people like Uber and Ola, they are using same type of analysis only. So these type of analysis, it will be useful for farmers at the time of transporting their produce from field to market. And another thing is, you see, in a short time, you can calculate the weather for whatever you are studying here. Just some 3 algorithms you can see it. with the help of 3 algorithms, next 100 years, what will be the temperature? And that is what I told you, the GIS, it will give you a very good decision support system. I'm not telling about expert system. There is a difference between expert system and GIS decision support system. Expert system is a structured one. Okay, it is a predefined solutions will be there. Whatever input you are giving, system it won't work much. Based on the if and else conditions, the answer will come out. So because of your based on your symptoms, this is the problem of your crop. So, but a decision support system not like that. We are giving the input to the system. System will think, it will analyze, and it will give you some 3-4 possible solutions. And then you have to decide it which is appropriate for your purpose. That is the difference between here. But with the help of these tools, we can develop a very good decision support systems. And again, market analysis, coming to the market analysis, you can monitor in each branch what is my manpower and what is their performance, who is performing well, who is performing very less, and you can shuffle it and you can improve your businesses. These are all the things you can do it with the help of this analysis. And again, you can identify who is your customers in market analysis and who is your competitors. If you want to establish a new retail store, where is the appropriate location and whether there is your customers are there or not. And again, supply chain management, if you see, so how you can route it your vehicles in a shortest path and fastest path. These things you can do it with the help of this analysis. These are all some of the analysis screenshot just I am sharing with you. With this, you can save your time and money also. Okay. And another thing here, a simple example I will show you. Just here, see, this is the metro path. This is the point future metro path I am having, and metro stops are there. Just these 2 data only metro path and metro stations. Now I want to do the analysis. The 15 minutes or 30 minutes safe zone area means if I start 15 minutes before, whether I can reach that particular metro station or not. I don't have only stops and the path. Other than these 2 data, I don't have any other data. In this case, the open source platforms today, they are providing n number of sources, like backside, whatever you are seeing, the map, street map, actually we added the backend as a street map. With the street map, with their data, in their databases, we are doing the analysis. Okay. So now if you want to develop a 15 or 30 minutes safer zone means, see, the analysis, it will, before doing the analysis, it will provide you options like this, whether you are going by walk or you are going by cycle or you are going by car, or this type of parameters. Once after fixing all these things, you will get the results like this. This is the first one. First image indicates the 15 minutes safer zone for that particular metro station. And the next one is 30 minutes safer zone. So how this analysis we did means, the street map road network we are extracting from open source by WMS services, and we can do it. That is what the beauty of this one. The external data, whatever, even our NRSC Bhuvan portal also available. They are providing many WMS services. Those services we can use it as a background and we can use it in our analysis. Okay, even Google and OpenSheet, many Bing Map, many are there. So their databases we can use it in our analysis as a WMS service. This way we can do it analysis, some of the analysis. And coming to the remote sensing resolutions. Generally, we are talking about 4 types of resolutions. One is spectral, spatial, spectral, and temporal radiometric. Spatial means how much area it will, that is swath, how much area it is covering. And spectral means how many bands it is holding. So these type of information, you will get it in the metadata. Whenever, if you open either vector data or raster data, there will be a file called metadata. Once if you open it, you will get it all the information, what temporal it is, what spectral it is, I mean, when it is captured, from which spacecraft, all these information it will be there. That is why metadata is very important in this context. And coming to this, the new era, now just you see, we are talking about open source software. The first image we received in around 1968. So that time, the image is 25,000 meters resolution. Okay, that is, today we are getting 10 meters resolution image, that is the Sentinel image. you see the technology improvement from 25,000 meter resolution to 10 meter resolution images we are getting free of cost. I'm talking. If you want to spend more, I mean, some money means even 3 centimeters resolution images also you will get it. 3 centimeters. Okay, very accurate analysis you will get it. Okay, up to open source, if you target up to 10 meters resolution images, you will get it at free of cost. With these images, you can go for different type of applications like nutrient management, water management, soil properties, different one, whatnot, anything you can do from sowing to harvesting, even after harvesting also up to reaching the market. Different type of applications you can develop it with the help of open source data on open source platform with the help of open source softwares. Okay, and see the resolutions. If we talk about the resolution, if you take it a same area, the resolutions 30 meter resolution, 20 meter resolution, the resolutions will looks like this. So for analysis, before analysis, you have to decide it what type of resolution image is sufficient for your analysis. If you go for high resolution images, suppose I want to district level analysis. For a district level analysis, I no need to go for a high resolution image. Suppose 3 centimeters, purchased image I'm talking. 3 centimeters image, if I purchase, it will be for entire district or entire state, it will be cost more. No need also that much high resolution images. So you have to see whether it is a 10 meter resolution or 30 meter resolution. These you have to decide it before going to the analysis. If it is a just natural disaster analysis, if you want it, so that is enough. 30 meter resolution is more than sufficient, or 10 meters more than sufficient. These things we have to take care before doing the analysis, what type of resolution is required. And out of these remote sensing images, we will extract the information like mineralogy, soil texture, soil moisture. Again, the soil moisture, the reflectance values only we are calculating. So we can estimate the soil moisture up to 2 to 3 centimeters, maximum 4 to 2 to 5 centimeters soil moisture only we can estimate it, not up to the root level and all. So the reflectance value, based on the reflectance value, all these values we can extract it, and different vegetation, indexes we can develop it. These are all the indexes, and this is the processing of images. Once after downloading the images, the cloud coverages will be there, especially during the monsoons. You have to remove the cloud. Sometime your study area will fall between 2 tiles. That time you have to merge these 2 tiles. That is called mosaicing. So we have to mosaic and we have to extract the study area in that. And again, see, this is the AVHRR data. One image, single image, the left side image, whatever you are seeing. So like this, after downloading, you will found, different coverage of clouds and all. So once if you start removing the clouds, different algorithms you have to apply to remove the clouds and all, it will take a lot of time to clear the entire image. Instead of that, first you identify your study area, you extract it, then you go for removing your, whatever cloud coverage and all. So it will save your time and quickly you can go for analysis. And after that, you can, whatever analysis, if you want to extract vegetation or temperature, you can extract it out of that images. Okay, these are all the some of the images. Openly you will get it, open source images. You can see so many are there. One of the one site I will show you. Is it visible, my screen?
Yes, sir.
So just you see, this is one, just USGA website I am showing here. If you want to extract information about a particular your study area, just after selecting your study area, whatever tiles you want, just here you see the data. Sorry. Here you can see after selecting the your study area, the next option is data sets. So if you go to these data sets, just I want to show you how many data sets are available. Here you can see n number of you. After expand this one again, so many. These are all the data sets you will get it. Now I am not discussing about all this data. Just for open source, how much data you will get it, that I am showing here. And here you see, including Sentinel. Sentinel, you will get it up to 10-meter resolution. That also it is available. This is one of the open source site out of this. Like this, n number of sites you will get it. Some sites directly they are processed information you will get it. Okay, but at the time of download, you should be registered under that. That is just a nominal registration will be there. And at the time of downloading, it will ask you login and passwords. Okay, these are all the sum of sources for downloading the information, and you will get it from almost 35 to 40 years with different resolution, different intervals data, weekly data, fortnight data, monthly data with different resolutions like 10 meters, 30 meters, 1 kilometer, 2 kilometers, like this. Different variation data you will get it out of this open sources, and these are all some of the open source software you can do the analysis. So one simple example, let me give one of the popular software like ArcGIS. For single license, they will cost around 12 lakhs rupees. So with the same analysis, whatever analysis you are doing with that software, same analysis you can do it with the help of all these softwares. Okay, so it is a free of cost. So that is what now with the zero budget you can develop with hardly 30,000. If you spend it, you will get one system. You can make it as a server also, that one, and whatever from desktop to up to server softwares, everything is open source only, including mobile apps. Everything open source softwares are available. Just a small customization, you can develop your applications. Okay, and coming to the open application, this is once again ESRI products. If you see mobile apps, these are all the mobile apps of ESRI products, and n number of mobile apps are available. So softwares. Okay, same software. If you see open source, these are all the open source software, different softwares and different purpose applications you can develop it. This is a very few I am showing here. Like this, you can n number of open source, and you can customize it according to your wish, according to your requirement. Okay, and there is no restrictions at all. Once after downloading, after customization, that is your product. You can go for free distribution or you can commercialize it also. That is the beauty of open source softwares. And here in starting slides, I told you about the Google Earth Engine. So recently, one of our concluded project we did on this platform. Let me explain about this project output. Here you can see out of this agroclimatic zone 10 we considered as a study area. And this is the total 45,000 villages are covered in this area. And all these 45,000 villages collecting latitude and longitude, it is a time consuming process. So instead of that, if you use once again, R software, R is again open source software only. With just 2-3 line script, if you put it, what we did here, let me explain. From census data, we collected district, mandal, and village name. 3 columns data we collected from census data, and these data with the help of R script, 3-line scripts, we posted on Google Earth. Google Earth already geo-referenced data will be there for each entire globe. So we are matching with Google Earth database. Wherever this district, mandal, and village name matches, that pixel latitude and longitude we are extracting through that script. Okay, that way the entire 45,000 villages data at a fraction of minutes you will extract it. Fraction of just it won't take maximum seconds. Within seconds you will get it, the entire 45,000 villages latitude and longitude data, and in between the gaps you can see in between. So this is because of missing data. So when you will get this type of missing data means wherever this, it is a case sensitive, wherever your district or mandal or village name, it won't match with Google Earth the database, there you will get it mismatch. The record it won't found, and there you will get missing data. So for that slight corrections you have to do it, and you can do it. So this is the one way how you can extract sitting in front of computer, huge data, how we are going to extract it. That is what just I want to explain here. And again, see, this is the study area, the complete agroclimatic zone 10, and you can identify the boundaries and perennial rivers. What are the perennial rivers around beside this? How much area is occupied? What type of crops? crops are growing. These type of analysis depends on your subject expertise. You can go for analysis, different analysis. And coming to this, here you can see December 1984, and again same month, December 2016, two images are here, the aerial photographs. I told you the raw data itself, some of the trends you can identify it. Instead of it is very difficult if you put it in the form of other databases. Okay, here you see the vegetation within the 30 years, a lot of the vegetation is dried up, and the canals, mainly these canals here you can see disappeared. Okay, these type of major changes you can easily identify, and it will give you a complete bird eye view on your data. In raw data itself, you can see the trends, how it is changing over a time. Okay, and again, this is here in this analysis we used Modi's data, and this is the Modi's grid. We have to identify your study area exactly where it will fall. And here in this study we used only two images. Modi's, they are providing total 64 products. 64 products, each product will provide you different type of information. Here, one type of image, that is MOD 11A2. It will give you the land surface temperature, and MYD 13A1 image, it will give you the vegetation index image. So here you can see one is 1 kilometer resolution, another is half kilometer resolution. And the temporal data also, one is 8 days interval and another is 16 days interval. With this, we can go for different type of vegetation index analysis and all. And another thing is here, whatever screen you are seeing, this is the Google Earth Engine platform interface. And here the left side window, the window, whatever in window here you're seeing, it will support Python and JavaScript here. You can with the help of small script, you can do the analysis, and you can predict the values next 100 years. See, this is the downside image. You can see this is the entire image. I no need to do the analysis for enter whatever study area. Suppose this is my study area. You just identify your study area and go for analysis. The next 100 years, how the temperature will be. These type of analysis here you can see two type of algorithms we use: RPC 2.6 and 8.5. In this, which is accurate and which is reliable, and error variation is very less. These things you can identify with the help of different type of algorithms. Okay, and if we are not familiar with much coding and all, see, these are all the libraries are available. Just drag and drop it, and it is a predefined pre-coding libraries. Just you can you have to do minor corrections. I mean, according to your analysis, you can customize it, these libraries, and you can go for analysis. Okay, and here you see the entire study area, the vegetation analysis, you can do it this way. And here, and one more thing, the village level analysis, the village is falling between two tiles. That time we have to mosaic, that is what I told, mosaicing, and we have to extract it. And you see the village wise analysis, what type of analysis we can do it, the complete season analysis. From June, peak summer, and after that, the sowing date will start. From sowing date to up to harvesting, the complete scenario, vegetation index, you can identify it, how it is changing, all these things. The greener indicates the vegetation, and in between you can see the red patches. It indicates the cloud coverages. If you are not removing the clouds clearly, entire images, during the analysis, you will get this type of missing data. Okay, that is why before doing the analysis, we have to be very much careful removing the clouds and all. And based on this, you can generate it, this type of indexes. Like here you can see there are indexes like water index. These are all two vegetation index. One is NDVI and EVI. Here NDVI, we are using two bands. One is near infrared and red band to extract the vegetation. Okay, EVI, other than two, we are including blue band also. It is more sensitive than NDVI to analyze, to observe the sensitiveness and all. We use these two vegetation index. Based on that, you can estimate the drought index. Okay, now this is it is a quite natural. Wherever drought is more, vegetation is less, and wherever vegetation is high, the drought is very less. Once if you develop this type of data sets at cadastral level, see, last November, December, we witnessed that huge loss because of the natural calamities and all. So whenever this type of floods or natural calamities, still we are depending on estimation and all manually only. One team will come from central and manually they are randomly they are selecting some samples and this much area is damaged, this much crop is damaged. Instead of that, if we have this type of index at cadastral level, at village level, crop wise, once again, it is easy to identify where in which stage the crop is damaged and how much it is damaged easily, mainly for decision makers and insurance purpose. These type of indexes are very much useful. And again, you see, this is the village boundary. And if you select the some of the samples and agricultural land, water bodies, and residential urban area and all, you can classify it with the help of supervised classification. One of the method is cart classification we used here. You can see the classification and extract the up to study area. Now I don't want to do the analysis for entire study area, only the vegetation part. In that case, you can mask the part, whatever you don't want, the water bodies and the urban area, you don't want to include in your study analysis purpose means you can mask it and you can hide those area. You can extract only vegetation area and you can go for analysis. Still, you will get better result than doing the analysis for entire study area. And here also, this is total vegetation. Here also, again, you can go for crop masking. In this, how much crop is under paddy, how much crop is under groundnut, how much crop is under cotton. Like this, if you go for crop masking and all, at the time of insurance or natural calamities, it is very easy. You will get, you have the information at fingertips. So in this stage, I mean, this much, this is the crop damaged this much. So I mean, it is very much useful for, especially for decision makers. Okay. So these type of applications, we can develop it with the help of this one. That is what in the initial stage I showed you with the help of big data. The people like Monsanto, John Deere and Walmart, they are developing applications. So for that, we need a huge databases. So those databases, the latest data mining tools like big data also we can incorporate in this analysis and we can go for this is another example. Here the surface water area with the help of remote sensing, how we are delineating the surface water area. This procedure we got a copyright and we got this one. Let me explain this procedure what we did here. See, once if a particular area images, if we collect it sometime during the especially monsoon time, the cloud coverage will be like this. If you want to remove the cloud coverages and all, if you go hardly, if you remove the clouds, you will lose the original data also. So that is, it is a very sensitive part, removing the clouds and all. So we have to, which type algorithm we are using, how we are going to remove the clouds and all. That is one thing. And previous platform, whatever Google Earth Engine, they are providing cloud processing images. Okay. And here you see, this is the study area for entire Telangana. For Telangana, what are all the tiles available and those tiles collected and extracted up to the study area. And this is the method we followed, whatever flowchart given here. Let me explain. Here we calculated three type of indexes. One is vegetation index and water index, two type of water index. Okay, one is normalized water index, normalized difference water index, and modified normalized difference water index. Okay, to see the difference between these two. And another thing is, each pixel, I told you, any index, if you take it, the values will be between -1 and 1. If you neglect the negative values, the values will be between 0 and 1. 0 indicates the lowest. I mean, if you take the vegetation, 0 indicates there is no vegetation and 1 indicates high vegetation. Okay. Now you have to define, you have to see what type of vegetation and what in each stage, the vegetation, the crop health condition, you can monitor it with the help of this vegetation only. And here in this case, just we are identifying the surface water, how much available in a particular season. So in this case, see the vegetation, whatever vegetation pixels will hold 0.2 and above indicates we are assuming that it is a more vegetation. And coming to the water index, whatever pixel will hold 0.3 and less value, we are considering that is a less water content pixels. If you identify these two type of pixels and remove from your image, and the remaining pixels are water pixels. In that case, we are identifying how many water pixels are available now in my study area and what are the surface water is available for that particular season. Here, just zoomed image, just to see before running my algorithm, how the image will capture the water bodies. Here you can see some of the water bodies, whatever that green colors indicate the water bodies. This is the aerial view of photograph, the water bodies and all. After executing the algorithm, it will capture the water bodies like this. Now we are calculating how many pixels it is holding, and based on that, this much surface water area is available like that. You can say it. So same this publication recently, last current science, we published this one, and it is correlating with this is quite natural only. Whenever rainfall is more, the surface water will be more, and whenever rainfall is less, surface water will automatically it will be less only. So these just we compared with Mission Kakatiya. Actually, in Telangana in 2014 end, 15 onwards, they started Mission Kakatiya renovating the water tanks to increase the capacity of water tanks. See, with these, if you compare with the ground level waters, you can observe it from 2013 to the ground. Blue indicate the groundwater levels, and very less groundwater levels you can observe 13, 14, 15. And when this project started, you can see the groundwater levels are increased. We are not talking about that project and all. Here we can monitor how the groundwater levels, either it is increasing or decreasing, that we can monitor it. And the same article we published in recently in a current science also. This is one way you can monitor it, and this will be very much useful for planning our next crop. See, before going for crop, what is the surface water is available and how much it will support, what type of crops we can recommend it. These type of decisions we can take it with the help of, if we know the surface water, how much it is. Automatically, if you have a surface water more, means automatically ground recharge will be more. The groundwater also it will increase. So based on that, you can suggest to farmers so which crop is suitable, and based on the water availability and all. So these type of decisions we can take it with the help of this one. And already I'm taking much time. With this example, I will stop here. Here you can see this is one type of decision support system. We did one as a case study for our demo purpose. This is also we got a copyright. See here what we did. This is completely Sensex data. This is completely Sensex data, and the structure will be like this. It will work like this. Forget about this. These are all the platform, how it will work and all. The interfaces will look like this. This is we meant for only for Hyderabad city. In Hyderabad city, here you can see the screen. Here we are using all open source maps. So this data we are not collecting. Just we are extracting from the open source images through WMS services like Google Street, Google Satellite, and Google Hybrid, and OpenStreetMap. Just we are extracting. Our data is the downline, whatever layers you are seeing, those are, we prepared the layers. One is land use and roads, wards, these information, income, location, streets, all these informations, we prepared the layers. These layers we are overlaying on our available open source layers and extracting the data. So this demo, what is the purpose of this one is, if I want to start a new retail store in Hyderabad, I want to establish a new retail store, which is the appropriate location, that it will give you a clear-cut idea. It will give you two type of options. Once again, by store you can search it, or by location also you can search it. If you see the location, suppose this is a Dilshuk Nagar and subdivision Dilshuk Nagar, and buffer area 1 kilometer, if we select it, the result will be like this. The result it will give you like this, and it will give you in this selected area, your competitors, these are all your competitors. Vijeta Navratan, one shop is there, and Spencer, 2 shops, Reliance Fresh, 3 shops are there, more 1 shop. Like this, who is your competitors in that area? That type of information it will provide you. And again, in that area, who is your customers? See, the income groups, it will give you like this. Total how many households, and more than 10 lakhs, how many, and 5 to 10 lakhs, 1.5 to 5 lakhs, and less than 1.5 lakhs. In this, you can decide who is your customer, what type of income group your customers. In this, whether your customers are more or less. And again, you can see your competitors also. Whether if you open any retail shop, you can compete with your competitors, and those type of things. Suppose it is not suitable for me, then you can shift your area somewhat near Medipatnam or some other Amirpet. You can search it, whether your customers are there or not, your competitors are very high or low. whether it is appropriate place to, establish a retail store or not. So these type of decisions, you can take it very easily. And one marketing side, one more example, let me explain it. With the one small study we did it for Uttar Pradesh on NPK utilization. Okay, so here the last slide I will explain, and I will stop my presentation here. Let me show you the last slide. Here you can see, yeah, the down image here. This image, if you observe here, the background, whatever the complete Uttar Pradesh, the background, it holds 3 shades. One is dark color indicates excess, light color indicates sufficient, and white color indicates shortage. Shortage of manpower, dealers information it will provide. Okay, and another, whatever pie charts you are seeing in district level, it is a top 5 fertilizers company. These top fertilizers company, what is their sales and all. Okay, now the company can decide, after seeing this analysis, the company can decide which area the manpower is more and what type of sales. Suppose here you see, here you can see the circle in size indicates the sales of that particular product. Okay, here you can see the sales are very less, and the background, if you see, the dealers are more, excess of dealers are there. But here is some places, if you see, sales are more and the dealers are very less. In this case, you can shuffle your staff, or you can you can recruit your staff to improve your business activities. This way, and even for supply chain management, even in agriculture, the pest management or crop monitoring, all these type of activities you can monitoring with the help of this geospatial technology. So here I will stop my presentation. If you have any doubts, I can answer it.
Thank you, Dr. Srikanth, for a very nice presentation. I think you have few questions in the chat box. Yes. Mr. Revati wants to have a detailed training program. Of course, NARM is organizing every year. And that we can just explain.
Yeah, somebody they asked how to set up a map layer for GPS data in QGIS.
Yeah.
See, I could not understand actually who is this?
Sir, I am Prabhu.
Tell me, sir.
Actually, we tried, sir. Actually, for we are collecting a diversity of insects.
Okay.
For that, I would like to put some maps.
So you are having a point features, point data, latitude and longitude. So
Yes.
put it, you maintain one CSV file. The CSV file, you can upload it either in Google Earth or QGIS also.
In Google Earth, we will get, sir, that one.
Google Earth, you will get it. Google Earth, you will get it, or QGIS also. Let me just, I am opening this QGIS.
Dr. Prabhu, I'll be answering your question in my next lecture.
Yeah.
I'll take care, Dr. Srikanth.
Okay. So
can I have your mail ID and phone number, sir?
Yeah. Your coordinator will provide all details with your coordinator. Sir, please share my number and email ID if you have any doubt. Whatever your doubt, the point data you can convert into CSV. That is what the text files or CSV files directly we can upload it in our QGIS. And you can go for analysis. Otherwise, if for visualization purpose, even Google Earth also, you can upload and you can see your data. Both way it is possible.
Okay.
Thank you, Dr. Srikanth. I think.
Sir, something you are telling regarding some training program at NARM.
Yeah, recently last week only we completed one training program. And next again August we are starting one more training program.
Same QGIS, no?
Yeah, open source with the help of QGIS and R both. Last week we completed 1 week training program. Same program we are repeating again. I mean, with actually due to this pandemic, we organized through online only. It is highly difficult monitoring the hands-on with the help of online and all. That is why very limited nominations we accepted. Next in August, by physically we are going to organize.
Please inform us, sir, during that.
Yeah, I mean up to date our website, we will providing all information, and we are circulating to all SAs, KVKs, and ICR institutes. Whatever program we are organizing, through we are communicating to the institute in charges.
Whoever is interested, you can just send your name. Whenever that advertise call comes, then I will inform.
Yeah, definitely.
Maybe in your website you may.
Yeah, we will post all our information on our website. Complete year plan you can see it on our website up to this March training programs. So now this is the end of this financial year. Now again April to next March, shortly we are going to upload our programs.
Okay, thank you, sir.
Thank you so much, sir.
Okay. So if there is no questions, then shall I leave?
Yeah, it's up to you, sir, or you can listen to me also.
Okay, no problem. Okay, thank you very much, sir. Thank you for giving this opportunity. Thanks for all audiences.
Bye, sir.
Okay,
See you in the next program.
Sure.
Dear participants, we are going to have next lecture, and whatever Dr. Srikanth has told, I'm just going to demo it in a GIS software called Diva, right? All are there visible? Can you just put on your video? People are there live. That's good. Good to see. Yeah, very nice. Nobody is driving the car or bike or going around in the field, isn't it?
Through GIS we can know, sir.
Yeah. But before listening, if you want to take GIS data in the field, you can go. Okay. So I'll be giving a demo how to use that Diva software, which is open source, developed by CIMIT. Developed by International Potato Center, Peru. So they mainly made it for potato. So now I'm going to just give a demo on that. So how to open the software or how to download it? Just to go to Google. Simply type Diva GIS, right? Then you will get this site, Diva-GIS, free, simple, effective. Just click on it. So you will get this first page, right? So here on this page, you have to click on the download program. Then you will have the latest version. It is the Diva GIS 7.5, right? Once you just click on it, the software gets downloaded. Apart from that, we can also download the other free data available. Free data in the sense that free shape files are there, which are soil related or temperature related or rainfall. All those data are available since from almost 10, even 100 years data also available, right? So these are some of the free spatial data available. So these are the country level data, and we have country boundaries we have. I'm not going to download the country boundaries because here the problem is Kashmir, they have divided. So that is the reason we should not use this map. So for that, we have to use that ESRA map. So that I already downloaded, I will be sending to you all, okay? Apart from that, we have global climate data. So we have complete global climate data. So in that, we have data from the olden years. Why this is coming again? Okay. So this is the global data. You will get it, the complete rainfall, minimum, maximum temperatures, and so on. Year-wise. Okay. Then species occurrence, we have some specific database. And also it has been linked with Genesis, where gene bank data also available, right? So this is about the downloading the app, right? So I'm closing this. So now I'm going to open the GIS software. So before that, I would like to tell that what are the data required for making the map, okay? So maybe already you heard from Dr. Srikant. So what are the data required? One is the spatial data, another one is attributing data. The spatial data is nothing but your latitude, longitude. Along with that, we can also add that altitude. And apart from that, whatever data you are collecting related to that point are called attributing data. So here what I am going to use is I am going to use two different samples. One is the exploration data. So whatever millet germplasm collected over last 20 years by IIMR. So whichever data or passport data is having lat-long data, so that file I am going to map it. Apart from that, I am going to use that passport data or the spatial data along with the characterization data. So these two things I am going to just give an example, right? So first let me open that Excel sheet. So this is Excel sheet is visible. Hello.
Yes, sir. Yes, sir.
Okay. So this is a passport information of millet germplasm collected by Indian Institute of Millet Research, right, over the last 20 years. And you can see that here the collector number is there. Then after we collect the material, we submit the material to NBBGR, we get the IC number, what is the crop name. You can see that all the 8 millets are here in the drop list. And botanical name, in case you collect the different species also, you can just map it. Then vernacular name and cultivar, materials, data collection source. So these are about around 54 different attributing data is available for this particular passport information. So the main information is latitude and longitude. Okay. Without this spatial information, we cannot map any kind of thing in the Jiva software. Okay. This attributing spatial information is very important. Along with that, we can add n number of attributing data, right? So this is the Excel sheet. So what we have to do it, the Excel sheet itself, you cannot just download it. If you want to use Excel sheet, that Excel sheet should be in the form of a 2003 MS Excel format. Okay. Otherwise, we have another option, that is text format. Text format is nothing but this particular Excel sheet we have to convert into .csv format. So that is what I'm going to do it now. I'm giving demo. Just to go to file, save as, right? Then convert into .csv, comma delimited format. Okay, what is the file name? The same file name I have given. Then simply save it. So it will ask, do you want to save the current sheet? Then yes. That's it. Okay. Now what is happened? This particular file has been converted into .csv file, right? Right. Now one CSV file is converted. So if you want to see that the CSV file, I'll just show the file. This is a CSV file. Okay. So this CSV file has this A mark in the Excel sheet logo. So Excel sheet will be without logo of A, and the CSV means converted CSV means you will get A logo. Okay. So this is the file. So what I'm going to do is I'm going to open the Diva software, right? I'm going to open that Diva software. Just a minute. some problem in opening it. I'm just, please give me 2 minutes.
Dr. Alagoan restarting his computer. Please wait for a few minutes.
I'm sorry, some software has stopped me to deliver the things. Now I'm going to just do that. You can see that software now, Diva.js. Hello? Hello?
Only white screen, sir.
Yes, sir.
Yeah, white only white only.
Okay.
Okay, top you can see Diva.js 7.5.0, right?
Okay.
Okay, so what I'm going to do is I'm just going to map it, whatever collections I have made. So for that, we already converted our Excel sheet, right? Excel sheet passport data into .csv format. Now I'm going to import the data, right? So import points to shape files. So import the data, the whatever data is in the form of text, right? Import point to shape file from text file, click it. Then input file, I am going to select where exactly the file is there. Okay, so that file is here. So just I am clicking it and open. Then automatically the output file name also will be created by the app itself, software itself. Okay, so now I am going to apply these points into a map format. Okay, simply go to apply. Then what it suggests, because some of the parameters, some of the attributing traits, they are we can call as variables. So they are bigger than 10 digits or so. So it will suggest you to reduce that title, the number of characters, right? So simply say OK for that. So I'm just saying OK to all the variables. It is already converted. Now you apply. Now I applied this all these data points where lat long data is there. Now that will be plotted in a map format, right? So it is coming, it is reading now. So the first thing is you should have a lat long data. Lat long data can be collected from the Google Earth, or you can collect it through the GPS. This is a GPS equipment which I used 10 years before. This is a Garmin 12XL. This costed 30,000 rupees that time. Okay, so to purchase this, I need to get a DRDO's permission that time. Now everybody's hand, they have the mobile and they have all the GPS data. Okay, so we have the latest GPS is this, and this is Garmin Oregon 550. Okay, this cost 56,000, and you will get all the information, tracking system, everything you will get it. So for collecting exploration or even for survey purpose, you can use this, right? So my lat long data is already plotted here. You can see here. So I'm just enlarging it. You can see that it looks like India, right? See all these points, wherever the points are there, I have traveled. Okay, I traveled and collected the jam plaza, right? So now I am going to add a layer. That layer is nothing but my India map, right? For that, I am going there to map, sorry, to layer, add layer. So here we have India map. So I'm going to add state map, right? Simply click on this. The state map, district map, everything I will give. That's it. Okay. So now you can see that wherever the collections are made, that is having the dots. In some of the area where in Gujarat, the dots are fallen on the coastal side or sea side. So that data we need to rectify it actually. So purposefully I have not corrected it. I have one more file with the rectified one. So these things we need to check it while plotting the map, right? So if you want to just enlarge the map, you can just do so, right? So this is the way, just plus or minus. So zoom out and zoom in, right? This way we can just do enlarging. And another thing is, if you want to know the information, okay? So each dot is a collection, right? So if you want to know the information, go to I. I means information, identity feature. Click on it and go to that particular dot, then it will give the information what that indicates that dot. See, that dot is E332, which is the little millet collection here. This is the passport data information. Here you can see that latitude and longitude information, right? So I'm going to another dot, maybe in Karnataka or maybe in Orissa. Simply go to information. Okay, this is a Kodo millet and collected. You can see the village name and all. Village is Amarla, Kesinga Taluk and Kalahandi. So this is the information about that particular spatial data, right? So likewise, we can have information. And if we want to know the information about this boundaries, okay, this is a state boundary, and you can just click on the information. And before that, you click the state, go to information, click on the state, and it will give the information about the state. So what I'm going to do now, I'm going to add one more map or one more layer over it, right? So that layer is a district map. Go to layer, add layer. This is district map I am adding. Open. So now you can see that state map, then district map also we have. And simply click on the district map. If you want to know about some district, go to I, then click on some of the district. Then this is the Kurnool district in Andhra Pradesh, right? And this is Sabarkantha in Gujarat. So like this is Kutch in Gujarat. So likewise, you will get information about the districts. One beauty of this map is you can add any number of layers, like that Srikant told. We can have soil map, we can have temperature map, we can have cultivation, or we can have population, or we can have the technology adapted, different crops growing. All those things we can map it. Only thing is all these attributing data will be linked up with the help of the spatial data, right? So that is the one. Okay. Now I'm closing this, and now I'm going to map. I'm going to have analysis, right? So before that, I want to know that, so this all the millets are looking in the same color. So I want to distinguish which one is the barnyard, which one is the sorghum, like that. So for that, we just click on the passport data. Here you can see on the sideline, we can have information. Just double click on that. Then you will get this small window. Therein, we can just select the which attributing traits you want to change it, right? Just to select. So I want to change the crop name. Okay. Just to reset legend. Then you will get automatically the software gives a different color. If you want to specifically change also, you can do so. I'm just going to select only sorghum. Sorghum, this is the color. Just to click on the color. It will give the option. Then click on it. I'll select my favorite color. Then I'm just going to increase the size of the dot or round circle. So I have made it to 4. Then click OK. Now apply. Now you can see that wherever sorghum is collected, you can see those data is in purple color. So remaining are other millet crops, right? So similar way, Dr. Ganiger, you can also, whenever you go for survey, lat-long data, you collect it. So you will get a village name, mandal name, and all these disease or pest incidents also you will get it. That percentage, everything you can add it along with the lat-long data, spatial data. Then you will get a beautiful map like this. Not only this, we can also going for analysis. I'm going for analysis now. Go to analysis. Now point to grid. So I'm going to check the richness of the accessions collected, right? Richness in the sense in a particular area, then how many accessions are collected, more accessions are collected, okay? So just to click on richness, and The data is already there, and the file is also already given there. Now, we have to select the parameter. So for which parameter you are planning to go for richness. So the parameter is a crop name. Just click on crop name. So these are the different crops, then apply. Okay, the where you want to save the file, you have to just indicate. So this is the folder I want to save that file. I'll just write richness map, save it, simply apply. So it has already calculated the richness based on the color. You can just see it. So why this color is now the color analyst map is in the first layer. The backdrop, there is a dot which is a passport data. You can just below that we have a district layer, and in below that we have a state layer. So if you want to just put over there, just drag this passport data to the analyst layer and also the state to the layer, then you will get the data, also the district. So now you have got the layer on the upside down, right? You can see now, I'm just enlarging it, this particular red part, right? Here more accessions are collected, this particular maybe Java regions. So here you can see that seven accessions are collected in these regions, right? So that is the indication of analysis, and also these areas. So here you can see, if you want to drag the map, you need not to just without disturbing it. You can see that there is a hand symbol there. Just click on that, then you can drag the map wherever you want, right? And this is another area where this Orissa and the border of Andhra Pradesh, wherein here also more than 7 accessions are collected, right? Here also more than 7 accessions are collected, and wherever 0 is there, there was no collection in that area, and wherever dark green is there, one accession, and then we have other green, we have 2 to 3 accessions, yellow 4 accessions, orange 5 to 6, and 7 accession is in the red color. So likewise, it shows. Okay, this is a one type of analysis. Okay, are you following? Any doubt so far?
Yes, sir. From starting now, sir, you have told regarding data from that. Quickly, you can go through, sir, from starting to end, sir. Quickly.
You are still in the starting only.
Starting means data layers is there now, sir. File CSV file we have made. Then next
Okay. Okay.
layer, then map analysis. Quickly, you can tell, sir, within
I'll tell that.
2 minutes.
Just deselecting these layers and all. Now you can see only the map, right? Okay. This is the map. Even that also, if you don't want, I'm just going to remove that. Just I'm going to add the layer. Okay. So before that, I would like to import the data. So go to data, import shapefile. The shapefiles are converted one in the text format, which is nothing but your CSV data. So go to input file. So wherever your CSV file is there, that you need to select it. So this is the CSV file, right? Millet collection 2000 to 2020. I have selected, then simply put open, right? So now you have to apply. So automatically it takes care of the latitude, where exactly the longitude data is there, latitude data is there. It will automatically take by the taken by the software. So now I'm going to apply. Okay, that file is already there in the current, right? So that is the reason it is not accepting. That file is already there. Okay. So up to this step is okay.
Okay, sir. Okay.
Right. So now I'm selecting all the files, just selecting it. So the next analysis, what I'm going to do is I'll select the data file, then go to the diversity analysis. So it's simply go to diversity analysis. We have different methods also here. We can also do some statistics here, Brilliant and Marglip, Shannon index and Simpson. So many methods are there, right? So here also I am going to select the parameter. Parameter is my crop name, right? Then all these crop names have come. Then simply apply. I am going to give that diversity map. That is a file name. Save. Then apply. So this is the diversity. Okay. So why this black color has come? The black color has come because of no data. So how to remove that? Simply go to that analysis part on the left side. You can see, you can find the legends, right? Okay. So just double click on it, right? Then there is an option called no data transparent, right? So no data transparent, just click on it. Then okay. Then those black spots, all grids will go off, right? So now here also again that I'm going to overlay the data. Okay, just I overlay. Here also you can see that the diversity, the maximum, not only maximum accessions, the more crops are collected in this region. Again, it is falling in the Jabwa Hills and we can say that Kalahandi, and also in Tamil Nadu also we have like Kolli Hills and so on. So this is the way we have to analyze for diversity as well as the richness mapping, right? Is it clear? So now if anybody has any doubt how they can map their data, if you have any doubt, just tell me, then I can give the solution how to do that. I already quoted an example with the Prabhu. Whatever he has collected, that those lat-long data has to be annexed with other attributing data like village, mandal, district, state, right? Apart from that, what is the severity in that particular location? Maybe you might have collected the data in 1 to 9 scale, or you might have collected the data between percentage like 0, 5, 10, 15 like that. So whatever may be the data, so those data we need to just put it, then import the file, and then you can go for the mapping, right? Then it will show that throughout the state. Okay, in this particular state, we have this is the severity, and according to the severity, the color boxes will change, right? So this is a visual data presentation. So we can nowadays we are using for many purposes as told by Dr. Srikanth in the previous lecture. Otherwise, a direct way for researchers, and this is highly useful. And maybe anybody else would like to add their map into this Diva, you can just ask me, then I can give the solution. Otherwise, I'll just proceed. Anybody has any doubt? Hello, are you there?
Yes, sir. No problem, sir.
You are there, I know, but others. For you, I am able to see. What about others? You have any doubt? So we can also put all this FLD data. See, wherever you are giving trials. Okay, already the FLD data is getting geotagged. So geotagging is nothing but you are collecting the latitude and longitude data, right? So the lat-long data is the spatial data. Along with that, you are going to get the farmer's information, right? Whom you have given the seed, how many acres, which variety you have given, when it was sown, when it was harvested, what is the yield he has obtained, and what is the cost benefit he has got it. All the information you will put it as other attributing data. Then automatically you will get the map. For each parameter, you can create the map, right? So this is how we can make FLD data, right? Okay. So anybody else? Not only FLD, even trial data also. That is the reason we are requesting all the scientists, whenever we send the trial, you please send your lat-long data. Okay. At least you can make a map out of that data. And this is the first trial IVT grain sorghum. That this many location it has gone. You just put all the yield data, not only yield. So you can put pest and disease and yield and genotypes. So you will get a beautiful mapping in by visualization, right? So this may be if it is multi-location data, generally it will be in different states. Then we can easily see that which state that particular variety is performing well. So that is one way of policy making, or maybe it can be useful for taking a decision, right? Even apart from that, we can plot the data over the years. Okay, the lat long may not change, but in the same location you are going to repeat the experiment, put all the 3 years, and then you can go for analysis also. So this data is there, but analysis part you will get all the information in a map format, visualization. That's all. But this will catch the people or policymakers very faster than you project the statistical analysis and other bar chart and other thing. So that is the thing, right? Okay. Any doubt? Anybody else?
Sir, I have one doubt regarding. I am trying regarding coordinates, but map we have to download, sir, separately in desktop.
Coordinates.
Coordinates I have made.
Okay, maybe if it is not downloadable, maybe the coordinates having some mistake. Maybe coordinates should be in the form of 2 digits degree first, okay, then dot, then 2 digits hour and minutes. Generally, we collect 8 digits actually using this Garmin GPS. And but for data purpose, we use only 6 digit. Okay, 2 digit degree in the beginning, then put a dot. Then afterwards, 2 digit hours and minutes, right? So in case if it is latitude, we have 0 to 9 degree. Okay, you are showing something.
Just it came, sir, like this.
Okay, this has the value. Well, you can do that. You go to information.
Here, sir, layer, sir, add layer.
You have a map. You have map with you, India map.
No, sir, that's I don't have. That's the layer.
But that is important, na? Okay, anyway, I will be sending you. No problem. Okay. So simply go to add layer, then you will have a India map. Okay. So that I will send to you. Okay.
Okay.
That is the one thing, and this is the way it has. This is which whole Karnataka or any specific district?
Whole Karnataka, sir. Whole Karnataka, Andhra, and Tamil Nadu.
So now I'm going back to again Diva. So this is the complete country information, right? If you want to see that how these state-wise informations are required, I want to know only the diversity analysis, the performance, or the number of accents collected in a specific state. You can also just remove the rest of the states, and whichever states you want to use it, that also it can be done. So for that, we need to go to district state map, double click on that. Okay, double click on the state, right? Then you will have a unique value. So in that state is there already, okay? Then reset the legend. So when you reset the legend, all the state information will come. Means here all the states are selected, right? So what you have to do, clear all. So I have cleared all the state, and I want to select maybe which state should I select? Will you go for Karnataka?
Yes, sir.
Karnataka is selected. Okay. Here I can also give some color for Karnataka map background. Background. So just double click on this. Then this is no fill. I'm just make a solid fill with maybe yellow color. Okay. Okay. Now only Karnataka is selected. Now simply apply for it. Okay. I applied, I closed it. Because other maps are selected, it is showing a complete map. I'm just deselecting this, right? Now you can see the Karnataka is selected. Only Karnataka is selected. Okay, so now only Karnataka is selected, right? So likewise, we can just make even state-wise, district-wise also you can get the information, right? So this is only for Karnataka. We can, if you want to remove Karnataka, other states here also, in the data also, then double click on the data. Again, go to state. Okay, now reset the legend. Then deselect all the state. Go for only Karnataka. So now you see that only Karnataka is selected for whatever collections are made. So I'm just enlarging it. Okay. So here also we had some confusion whether this is belongs to Karnataka or maybe the neighboring Maharashtra state. So some data are there like that. 2, 4, 6 collections are made like that. 6, 7, 8. So maybe by mistake also it might have happened, or this has to be queued. So rectified it, right? So here you can see if you want to check the data, simply go to I and click on this, and this is VKEB. It is collected by NBBGR, and you can see the data, right? This is the way we can also select the state-wise mapping, right? Any doubt? If you want to know the passport information of the particular dot, you can just select that. Then go to this table. There is a table. Okay. So here you can see the complete passport data, whatever we have already projected. So that data you will get it, right? So there are about 2,696 data records are there. Similarly, for state information, simply click that state and then go to table, and it will give the state-wise information. So here only the state boundaries are there, state information is available. Apart from that, for each state, district, what is the population and what is the cropping pattern and the soil types, whatever you want to add it, and that also can be done. Nowadays, all these maps are available free, and you can go to the Maps of India. There also few shape files are there. .shp, that is a file you can just use as an layer, not any other kind of file. .shp is the extension thing, and only those files you have to use, right? Is it clear? Any doubt, you can just ask me. So, no doubts. Very good. Okay, shall we close this lecture and go to MS Excel? Hello. Hello.
Yes, sir.
Yes, sir.
Yes, sir. You can continue, sir. We are all here.
Thank you. Thank you. But I should get some sound now, so that otherwise I will sleep.
Yeah.
Thank you for listening. And now I am going to take you to the MS Excel, which is Ramana.
Yes, sir.
Okay, no, you want me to close it, or I will continue?
No, sir. You can continue.
Okay. So
I will
yes, thank you, sir. So now I am going to take you to the Excel, the kingdom of Excel, right? So Excel is an excellent platform wherein you can have a beautiful database. You can make a beautiful database with any kind of data. Okay, I'm going to just give a demo, and some of the things which you may be knowing better, and some things maybe some people may not be knowing it. So that I'm going to make a demo, right? So I'm going to open an Excel sheet wherein I have already made some problems, right? And I am going to just give a demo on that, right? So this, let me close this Diva. Yes. So my Excel sheet is visible.
Yes, sir.
Visible.
Okay, that's good. So I will just enlarge it, right? Oh, this is the data file of barnyard millet which we characterized last year, 2021. So I have taken uniformly the barnyard millet file for knowing the data as well as for the easy interpretation of the data, right? So the first one is what I'm going to tell you is conditional formatting. What is conditional formatting in Excel? And that many people may know and may not know. People may know it. For conditional formatting, go to that home. There is a conditional formatting available here. Those who are sitting in the with a computer, you can just open it. Go to conditional formatting. What I am going to do is, before that, I am going to select this column. Okay, in this column, I want to know which are the entry are duplicated. Okay, so which are the entry I want to know duplicated. So I have just selected that column. Okay, then I am selecting the conditional formatting. Then I will select duplicate values. Right? Now the duplicate value are in pink background. Okay, now you can see the color. This is the background. Okay, so now I want to just filter what are the values which are duplicated in this particular column. So simply go to filter. You know what is filter? Anybody knows what is filter? Those who are not aware of it, I'm just click on the cell, go to sort and filter. Here in the same home toolbar, just click on filter. You will get a arrow mark here, drop list, right? So drop list, you click कर लीजिए. Then you will get filter by color. There are different options available. I'm going to filter by color because my duplicates are colored in pink.
Filter कहाँ से आता है?
Okay, so now you can see all the duplicate values are available, right? See, these are all duplicate values, or maybe appeared more than once. Okay, so now because these are all checks, so these are all checks, that is the reason it has been repeated. Okay, so every 100 entries it has been repeated. That is the reason these entries are considered as a duplicate. Okay, this is the one called conditional formatting. I am removing the condition for this particular cell. Clear rules from selected cells. Okay, now I cleared. So now what I am going to do, I am going to take one value, right? I am going to take this number of bases to less. So I want to see that the value in a map format, right? Again, I am selecting the conditional formatting. Here what I am going to do, we can have the greater than, less than, between. All these options are available. So these options can be made in several ways. It can be made through filters and it can be made through mapping also, right? So this I am not going to touch it. So what I am going to do, so I will select the top 10 values. If you want to know which are the top 10 values, click top 10 items. Okay, so that will be highlighted in the pink. Okay, again go to color. Then these are the top 10 values which I am having in this number of tillers. So this is the way we can just select that. Okay, these many accessions are having, sorry, these are the entry name, and these are the value of number of tillers. So my top 10 value for the trait called number of tillers, and this is the result, right? So this is the way we can just select the accessions. I'm just deleting the rules. So clear rules from selected cell. What I'm going to select now, the next item. Okay, here similar to that, we have top 10% and also bottom 10%, average, above average. This is also another thing. So if what are the values which are having more than average? Okay, they are somewhat better entries. So click on it, then select the color, and out of this 553 accessions, 224 accessions, you can see number here at the left side corner bottom. So out of 553, 224 lines are having more than above average, more than the average, right? So if you want to just sort it out, you can just click on the window, column, and go to largest to smallest. Then you will get the value. Always you have to accept. Once this is arranged, automatically the related column also will get changed. Okay, for that expand the selection. So that it will expand till whatever the rows are related to that will get expanded. Sort it. Now you can see the more number of basic pillars are in accession with 16.5 in IC number so and so, and followed by the next 12.3, 11 like that. So it will be arranged on the descending order. Okay. So this is the way we can filter the data. Okay. Is it clear? Hello. Okay. Right.
Yes,
so
sir.
I'm just canceling the rule, clear the rules. So I'm going to take another value, days to 50% flowering. So here the another conditional formatting is I'm going to make a data bar. Okay, data bar in the sense we have different gradient colors. You can see, just simply click on it, you will get the different colors, right? So this color I am selecting, and this color shows this will convert it to 100%, and based on the value the bar will look, right? If you want to know which is the topmost value, then select this, or you can just select the whole column, go to the sort, make it to largest to smallest, right? Now you can see the maximum number of days to 50% flowering was in so and so entry with 87 days. Okay, then it will gradually decrease. You can see. So it will show in a pictorial format whatever data you are seeing it. All will be arranged in a pictorial format. Okay, you can also select this data and create a map also. Okay, separately. So that is also possible, right? So I'm just deselecting it. Means I'm clearing the rules. Okay, so this is another set of value conditional formatting. Apart from that, we have also color scales. So these are the color scales wherein it will give the gradient color based on the value. See, if it is the highest value, then it will give the dark color, and the lowest value, then it gives the lighter color, right? So here already this is shorted. So I am making it to smallest to highest. Oh, sorry. Here it is. Red color is the early flowering one, and then wherein the green color is the late flowering one. You can see how that color gradients are changing when the number of days to flowering is changing. Accordingly, the color also will change. Okay, this is the way we can just present the minimum maximum temperature, right? Even if you can also project the rainfall data, right? So this is another kind of making the conditional formatting. This I am clearing the rules, right? The next one is we have icon formats. So here the icon, what it does, we have different icons like arrow mark, top, up, down, and also the bar or average, we can say that. So it will take the average value, and then it will give the whichever value is the lower value, it will give the down arrow. Whichever is the upper value, it will give the up arrow. Then we have average. Like that, it gives a different statistics, right? You can see through the arrow mark, right? This is another conditional formatting. For this icon set, black and white, you can see that automatically it changes there. Okay, we can make a triangle You can other arrows also you can make it. So if you want to add here star mark, like say for example, the battery charging. So when you get the signal in your mobile, how the battery is, whether it is fully charged or it is less charged. So this symbol also you can use it for picturizing the value. Also we can have the circles. So full moon or the Amavasa, we can call it a no moon. So that way also we can make it. We can also make the rules. How to make the rules? So this, what kind of icon style you want to use it, you can select it, and then we can have the values. Okay, that means it is 67. Okay, so the highest value is 67, or this value is 67, and we can convert into 33 to 67 and less than 67. Like that, we can make or change the values also. So that way also we can make the conditional formatting, right? I'm clearing the rules now. Any doubt in conditional formatting?
No, sir.
You have to play with that. Then only we can learn about it, right? Right? So I'm just moving to next. Okay. So next one is merge and wrap text. So how to merge the cell and how to wrap the text, right? So wrapping, you know it, and just go to the text. Okay, this is the two cells I want to wrap it. Then right click. Instead of right click in the text format, you just go to wrap text. Okay, simply go to wrap text, then it will accommodate into a single column. Okay, simply go to wrap text. If you want to merge, these two styles, go to simply merge it. Then two columns get merged. Okay, if you want to split also, you can do so. Just simply go to split cell. That is also possible, right? We can split means we need to give the number of split, maybe how many columns you want to split. So those details we need to give. Generally, this is being used when you have a character. Under that character, we have replicated data, or maybe the number of plants 1 to 5 or 1 to 3. So if you want to see that all your heading in one column and all your subheadings, say for example, first plant, second plant, third plant in second heading. So that way, I think this is useful for projection, right? But while making filtering and going for analysis, this will not work. Okay, for that we need to remove this, and we have to select only the data. So that is also very important. So this is merge and wrap text. Okay. Okay.
Split means unmerged cells, no, sir?
Yes, split cells also we can make it. We have option. Unmerge cells.
Okay.
Unmerge you can make it. So now the two cells are unmerged. Okay.
Okay.
So now I'm going to take you to the filter format. So I'm using the same data, right? So filter where it is available in the first conditional formatting itself. I told you that where is the filter. The filter is available in the short and the filter format. Just click on it, go to filter. Simply go to filter. So now you'll find an arrow mark, drop list there in each variable, right? Simply filter it. So what I'm going to do, maybe I'm going to filter this based 50% flowering. So when the filter option is clicked, you will get the lowest value at the top, then highest value. You can just drag this arrow, then you will get highest value in the last, right? So what do you want to filter? How do you want to filter? Go to number filter. How do you want to filter? You want to know simply the value. Simply click equals which number you want to see. Say I want to know how many accessions are having the 55 days to 50% flowering. 55 days, right? Simply type 55. So whichever accessions are having 55 days of 55% flowering, it will show you. My goodness. 55 is there or not? Okay, I'll select. Okay, I have deselected this. That data is not. Here also you can do so. 55. Then enter. Here what happens then which the entries which are having 55 days to 50% flowering. Out of 553, we got 54 entries are having 55 days to 50% flower. Okay, this is one way of checking. And if you want to know the lowest, right, simply go to the less than or equal to. Maybe I want to select the entries which are having 50% flowering less than 50 days. Okay, so less than or equal to 50, less than or equal to 50. Click on it. Then here we have 69 entries which are having 50% flowering less than 50 days. Okay, here you can see. So these are the entries, right? The IC number, then we can go for selection, right? If you want to know the greater than, similarly, we can select greater than or equal to, or if you want to know between, or if you want to know top 10 or below average or above average. So all those combinations you can just make it. So this is another way of filtering the data, right? Is it clear? Hello.
Yes, sir. Yes.
Okay. So now I'm going to take you to pivot table. How many of you know what is pivot table? What is pivot table? Have anybody has used it?
Where it is there, sir?
Pivot table, anybody has used it?
Sorry, I listened that the pivot table, but I didn't use that table.
Okay, okay. I'm just going to tell you how to use it, right? So this is my data. This is my barnyard millet complete characterization data. This has all quantitative data as well as the qualitative data, right? So what I'm going to do is I'm just going to make a pivot table. For that, we need to just select that Excel sheet. Automatically, that it will select also. Simply go to insert. Go to insert. Then on your left side corner top, you have a pivot table. Simply click on it. Then automatically your data gets selected. Okay. Then where do you want to have your pivot table? If you want to have within your worksheet, you can have it with the existing worksheet. If you want to have it in new worksheet, then you click on new worksheet. Then I have selected new worksheet. Said okay. So this is the pivot table, right? So this sheet name I'm changing it to pivot. Okay. Now this is the query option. So these are the variables available on your right side. So whatever variables are there in the Excel sheet, all quantitative, qualitative characters are there, that is available, right? So what I'm going to do, I'm just going to, okay. So this pivot table, I would have used something else. Anyhow, let's put it on 1 minute. Okay, so this data only I will use it. Okay, so this pivot table, I'm just going to select the qualitative traits first. Okay, the qualitative traits are here. We have leaf sheath pigmentation. Let me take the more variation wherever it is. So I will take plant growth habit first, right? This I have selected. There are only two scores here. The one is a decumbent type and another one is erect type. Okay, there are two scores available. I've selected, and the selected one will come as a row heading. Then same character, just drop it here. Just drag it, drop it in the value. Just drop it, then you will get the value. Okay. Next character I'm selecting, leaf sheath pigmentation. Again, 2 are there. Inflorescence shape. There are about 3 characters, arced, diffused, and globose elliptic. Simply drag that shape here in the value. You will get the value here. Okay. So I will select panicle compactness. Again, 3 types are there. Simply drag it, put it in the value, you will get the value. Okay. After dropping it, if you want to just make the score in descending order, again go to filter data, largest to smallest, so that whichever the character or whichever score or state of a particular character is more, that will appear first, then it will be in a decreasing mode. Okay, so that we can easily conclude in panicle compactness that intermediate types are having maximum frequency followed by compact and open. This is the way we need to report it. Okay, so in addition to that, if you want to have more more queries, say for example, I want to have panicle compactness data, right? Along with that, I'm just longest to smallest. Then along with that, I want to add this inflorescence shape. Okay, then you can add here in column. So this will create another kind of report. So here, what it does, intermediate is the panicle compactness, in which, right, in which arced types are 178, sorry, diffused types are 162, inflorescence type, globus are no. Okay. Yeah, 178, 162. So it gives the bifurcation. Okay, arced is 178 and diffused is 162. So likewise, we can make a number of connections between the characters, right? I will take another example. Grain shape is there. So all are two characters. So here I have taken the grain shape under elliptical shape. Value also I am putting it. So under elliptical, there are about 80 grains are having elliptical shape, in which gray color we got 7, light gray 25, straw white 48. Okay, so likewise each character, then the added character. For added character also we can have a complete number. So this will be very easy for you to just make a report. Is it clear? Hello?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
I will call. Is it clear now? So this is the way we have to make the filter table. Okay. So now I am going to take you to this is over, filter is over. So I wanted to show this collection information for my pivot table. So once again, I will just use this collection table for this purpose. So collection table, insert pivot table, new worksheet. Okay. So now this is my passport data, right? So I want to know how many accessions are collected in each state. So out of so many accessions collected, simply select that the state information, bring the state into row heading. Then we have the number of accessions. Even if you bring it state also here in the value, you will get the complete information, how many accessions are collected in each state, right? Simply filter it and largest to smallest. The maximum accessions are collected from Maharashtra. Okay, maximum accessions are collected from Maharashtra, followed by Andhra Pradesh and then Tamil Nadu and so on. If you want to again make one more table out of this, in each state, how many crops? Each state, crop wise, I want to filter it. Okay, you can add that crop information. Crop name is here. That you can take it to the column heading. Okay, now what will happen? Each state crop wise information also will get annexed to it. See, Simply just drop it, will get in Maharashtra, 1 Bristol foxtail, 12 finger millet, 25 foxtail, 8 kodo millet. Okay, then no little 16 pearl millet, 6 proso, and so on. So total is 479 exercises. Okay, if you want to add even one more character, say for example, I want to add state also. So you can add the state here in the row column. So each state followed by, district, each state followed by district also you can make it. So now just below the state, I'm adding the district. Now you can see that in Maharashtra, these are the districts we have undertaken exploration, and district wise the crops collected. So is the state and district and number of crops collected. Okay, the data is simply in Excel sheet. When you just make a pivot table, it gives beautiful reporting mechanism. Then this is how I am making most of my database, and now also 3 databases it is running, and we are going to publish it in our annual workshop. Is it clear? Hello?
Yes, sir.
Yes,
Okay.
sir. Yes, sir.
So now I am going to take you to illustration. So apart from other conditions, we can also insert pictures. We can insert pictures. Okay. We can insert picture from your hard disk or maybe some other source. That is also possible. Okay. Then apart from that, we can pictures. I'm just inserting it. Okay, you can reduce size and everything. Then we have insert option of online picture and also screenshot. This screenshot is very important because people who are making the manuals, like a flow chart, and first step is this and second step is this. So for them, I think it will be useful. This is the screen. My screen, it has taken as a shot, see, screenshot. So I can just reduce it. This will help for preparing the manual. Okay. After inserting this screenshot, we can put the conditions or whatever comments you want to add to this, that can be done. This is another way of using illustrations, right? So next one is a recommended chart. Okay, recommended chart, generally what we do in Excel sheet, you just select the data, then you will chart will come, or you will select, you will go to the chart, whichever chart you want to make it, maybe bar chart or dot or whatever way you want it. Okay, so but there is an option called recommended chart. The app itself will select some of the chart type, right? So that I'm going to just tell you. So I'll take the 50% flowering data. Once you just click that column, then go to recommended chart. So once go to recommended chart, it will give how the best way this data can be presented. So it will give an option. One is through scattered chart, the another one is through the line way, and the third one is the histogram, and fourth way is the Pareto chart. So in this Pareto chart, you will get the range between 53.8 days to 57.7 days. So likewise it gives, and here this is here also we'll get a histogram, also will get the range, and here the simply the line will be made, and each dot, each data will get connected, and here in scatter chart the data will not be connected, only it will appear on a dot format. Simply select the dot, whichever is deviating value, whichever is lower value, whichever is higher value, you can easily select it. Hello? You can easily select it based on the scattered chart. So these are the recommended chart, not only for a single variable, we can also go for 2 variables. Say for example, I'm just selecting panicle length and width, right? 2 columns I have selected. So go to recommended chart. Here also it gives that width at X and Y in the length. Okay, similarly, the chart title here also, the top length and width. And this is also another way of, so these are all recommended chart, right? So instead of selecting yourself, and you can just before proceeding, then you just check the selected recommended chart so that you will get a appropriate map or appropriate bar chart, right? This is another thing which I would like to tell you, right? Is it okay?
Okay, sir. What is the difference between normal chart and recommended chart, sir?
Normal chart, you have to you just simply select it, and you will have whatever options, what you think that data should appear or data should be visible. Recommend chart will be selected by the app itself. It will suggest you that if you just use this chart, it looks nice. So that is the way it gets, it recommends.
Okay, okay, sir.
Okay. When you go to sweet shop, maybe your son will recommend you, you get me Mysore Pak, but after going there, you will select your one laddu or jalebi, right?
Yes,
Something
sir.
will be recommended or something you will do on yourself. So that is the difference. Okay.
Okay.
You can prefer both. You can take both laddu and Mysore Pak. Okay.
But many times we don't know which type of graph will be better for
better.
data.
Yeah.
Then if you go for the recommended chart, it will show that.
Yeah, exactly.
Okay, sir. Okay.
If you know which type of graph is better for your data, then you can select yourself.
Yeah. You feel better, you can select, but whatever the system feel better, that you have to go to recommended chart.
Okay.
So I'm going to take you to the next thing, text symbol and equation, and this option is already available there, and maybe I don't know whether everybody knows it or not. So here you can just add equations inside, and we have symbols here. I think many know it. Now, apart from that, we have got different equations. So say for example, for writing thesis purpose and all equations, you not type it simply. You can make it and use it as a different file format, and this can be used here. So that also can be done. The next one is join and split cell, right? So this join and split cell, and I want to just give a demo how to split a cell and how to join it. Okay, this is IC number, right? This is IC number with 7 digits, IC with 7 digits number. So, but this is not in order. I have made it order now. Okay, no problem. So, if sometimes the IC numbers or whatever number you are having, that may not be in order. Okay, so that will have prefixed or suffixed with some alphabets. Okay, whenever the data is having prefixed or suffixed with alphabet, you cannot sort it out. So for that, we need to first split that number, then we have to sort it out, right? So here in this case, the IC number is prefixed. Okay, still I don't want to use it. This one, I'll select one more. Yeah, this again. I will select this one. Yeah. So this is the sheet IC number. Okay, now you can see that the numbers are not in a order. Okay, so what we can do is we have to split it and make only the numbers. Then you can have the sorting of numbers. Okay, for that I am going to split it up. There are three ways of splitting the number. The first way is you can just simply select the whole column. Go to find.
1 minute.
Yeah, Hari.
Why it cannot be sorted? It can be sorted, sir.
It cannot be.
Yeah, if there is space, then it won't. If there is no space, like the characters, the numbers, what you have given, it will sort it.
Yeah, exactly.
If the
space is there, yeah. Space is there, then it cannot be. Yeah, that is also another condition. Yeah. So here earlier IC numbers they won't put this 0 was not there earlier. So they will give a space, then followed by 6 digits number were there. So what after that they wanted to make it to 7 digit, then added 0. And some people will use IC space 0 and some people will use IC without space. Okay. So one way of doing it is to just to find IC, go to find, then find what you simply put IC, then replace with nothing. You don't want to replace with IC, that simply replace all. Then say okay, then now we have without IC number. Okay, this is without IC number. Now I want to sort it out. Simply go to sort out, then smallest to maximum, longest. Okay, now these numbers are sorted out, right? Now you want to add the IC number. Okay, how will you do that? So for that we need to just put the insert. So put IC here. So IC I kept it separately in another column. So I want to unite this A column and B column. Okay, I want to unite A2 and B2 cell. Okay, for that the simple formula is press is equal to, right? You put the cell address. Okay, then put under. Okay, then if you want to space, you give space. Before that we need to start with colon, and then without space means if you want to space, put space here. Okay, otherwise no space. Again put another colon, then and then select the next cell. So this means you are adding or merging A2 and B2. Simply select, that's it. So now what it has IC number, then followed by the number. IC, then followed by number. Simply double click. Once you double click, the same formula will apply to the rest of the field. Right? So now you can see that all the numbers are having prefixed with IC. Okay, this is the way. If you want to add a space, then change the formula. So this is the formula here in the top. So simply put space, enter. Now you'll get IC space, then you will have the number. Okay, so if you want to add something more also, you can add it, and you can merge any number of columns. Okay, this is the way when you have a common thing to be merged or added, so that can be done. So if your comma or semicolon or colon, if you are using invariably, then you can just merge or you can split the cell. Okay, this is the way we have to join and split the cell. Is it okay? Hello.
Yes, sir. Yes, sir.
Okay, thank you. So now what I'm going to do, how to split the text to column. That is what I was telling just 1 minute before. I will select some data. Where is my data? Just a minute. So this is my plant rate data of this year, Rabi 21-22, right? I'm just copying this file. So this is my plant rate data. So in the field book app, we collect the data, and generally we make plant number 1, plant number 2, 3, 4 like that. So when you have different columns, then each data will go to different columns, like first plant, second plant, third plant, and fourth plant. And fifth plant and sixth column you can ask for the average, right? So that is a one way of doing it. Another way is in the same plant height, we can also take all the plant height at one cell. Okay, here only one plant is there. If you have 3 plants, then we should have a colon, semicolon or a colon or comma or plus, whatever special character you are using, that should be common among all the data wherever you are collecting. Okay, so this special character will separate your data. Okay, so wherever you are using colon, then it should be used uniformly. Then collect the data, all the 5 plant data at one single cell in a digital field book. I am telling tomorrow again. I'm going to tell you that. So 160, then colon, then 170, then 170, 165, 190, right? Then now after collecting the data, this will be exported. Exported data will be like this only. So now I want to split it, right? So I will split the data into 5 plants. Okay, how to do that? Just go to text. I'll just select all the column first. Huge data is there. Okay, I'll select up to here. Okay, so now there is a format called in the data. There is a text to column option. Go to text to column. Okay, click on it. Then you can see the data, whatever data you just selected, you can see it. Then go to next. Then what is differentiating? What is splitting the data? Which character is splitting the data? We need to address, or we have to give it. So whether tab is splitting or semicolon or comma space, just to give this. Once you click, put that character. Okay, you just see I'm repeating it. Once you put that character, semicolon, then automatically all the 5 data gets splitted. Then go to next, then finish it up. Now you can see that all the 5 columns are splitted, and first plant height. Then we have second. That's it. So now all the data is splitted. So this is another way of collecting the data very quickly, instead of having going to each cell, each character and collect the data. So this is what I told my people to collect the data. So now they are using this semicolon and simply, and they collect all the 5 plant height, whatever quantitative character they collected, and I will just simply split it and put it in the different cell. Okay, any doubt? Hello?
No, sir.
No. So I will go to next option. This is remove duplicates, right? So earlier in conditional formatting, I was telling you how to identify the duplicates. I think everybody knows about it. Simply go to conditional formatting, then go to duplicate values. So that will be arranged in the pink in color background. Okay, this data is without duplicate. In the last class, I removed the duplicate. Okay, no problem. I'll select that file again. So here I'm just putting conditional formatting. That is another way of identifying the duplicate, right? You can see here. So wherever the duplicates are there, the background will be pink in color, right? So now I'm removing this condition. I don't want to see the duplicates. I want to simply remove it. Okay. Simply select the column. Okay. Go to data. So here there is an option called remove duplicates. In data, there is an option called remove duplicates, right? Simply select it. Then it will ask you, do you want to expand the selection? Okay. Then remove duplicates. So then it will ask you which column do you want to remove the duplicates, or which column the duplicates are there. First you unselect everything and select which one, MGP number, Millet Gene Bank number, where duplicates are available. I am selecting only that variable. Say OK. Now it will give the result 26 duplicate values found and removed. The 529 unique values are remaining. Okay. So this is how we can just remove the duplicates. Clear? Hello?
Yes, sir.
Okay. So now the next one is the data analysis, I think. Should I tell the data analysis part or no need? Yeah, this Excel has data analysis part also. What I will do that these are the quantitative characters for which I am going for analysis. And in the data itself, the data tool itself, there is a option called data analysis. Okay, once you click that, then I will go for descriptive statistics. Then I am going to select the data input range. So I am just selecting the input range. So this is my input range.
Sir,
yeah.
First, you have to tell to bring that data analysis tool back.
That I think many may not be having it. Okay. So if you are not seeing that data analysis tool, I think we need to get it from the file option, and here we have the add-in. Go to add-in, and here we have the data option will be here.
How to go about it, sir? Excel option.
Yeah. File, then here go to option, then here in add-in. I think it is already there. That is why it is not showing it. Go to add-ins, then there you can see that data analysis, then say OK. Select and say OK. Analysis tool pack. You can see add-in analysis tool pack, then OK.
Tell me.
It will be added there. Okay, now I am going for analysis part, then descriptive statistics. Then I am selecting the data.
Yeah.
So this is my data input range. Okay, so the first row contains the labels. Okay, you select that. Then output range also you can just select it. Output range I am just giving here.
That's interested now.
And here I want to have the output and summary statistics. I want then say OK. Then your data gets analyzed, right? Then I'm just deleting the first title, shift the cell to this cell. I will move it to.
ఎందుకే ఎలా
Now you can see that wherever the empty cells are there, those things you can remove it. Okay. So this I'm removing it so that only the heading part will remain. For that, simply only one cell, you just move it left. Then delete these all other columns. Right, now we have data here, unlisted data. And this data can be presented in other way around also. Just a copy, paste it to transpose. Okay, now the characters will appear on the left side as a column heading. Right, then we can just reduce the digits, number of digits. So now your table is ready. So this is a simple descriptive statistics available here, and we can.
Sir?
Yes, madam.
Sir?
Yes, madam.
Yes, sir, ट्रेड्स को आपने ये वर्टिकल कैसे कर दिया?
ये राइट, ये करना राइट, ये पेस्ट करना है.
हाँ.
पेस्ट करे से आपको ट्रांसपोज बोल के देना है. एक मिनट, ये कॉपी कर रहा हूँ, ये कॉपी कर रहा हूँ. राइट क्लिक करके यहाँ के जहाँ आप पेस्ट करना चाहते हैं राइट क्लिक करिए, करके इधर थर्ड फोर्थ ऑप्शन है ट्रांसपोज.
यस.
ओके, यहाँ ट्रांसपोज करेगा उल्टा हो जाएगा.
ओके ओके सर.
राइट मैडम, राइट. So I will take you to the next item, that freeze spans. So freeze spans also we can freeze the first column or the first row, whatever way you want to freeze it, you can do so. You go to, I'm just planning to freeze because once you freeze the first column heading, then data will be visible, also the heading. Okay. Now when you just scroll the bar, then you will not see that heading. So to freeze that, we have to just select the first row, okay, where the title is available. Then go to review. Sorry, go to data. Right. Go to view. Sorry, go to view. Then freeze spans. Freeze top row. Once you do that, then top row will remain static and simply move the data. Okay, now you can see that while scrolling, that top row will remain static and the remaining data is moving, right? So we can also unfreeze it. Go to right click and you can also unfreeze the top row. Okay, similarly you can also freeze that columns. So freeze first column. Okay, or maybe you can freeze this. Maybe it is first column only. Okay, when you just move this row-wise information, the first column remains static and you can just move. Okay, so you can also unfreeze it using the freeze span, unfreeze pans. Okay, this is freezing and unfreezing while selecting or while using or checking the database. I think this will help you to save time instead of scrolling and seeing the headings. Okay. So I'll go a bit faster. Next one is hide and unhide. Here in hide and unhide, say for example, here, this is my complete data and I want to see only the IC number. Okay, I don't want to see that other MGP number or other ID. Simply select those columns which you do not want to see it. Okay. Simply select those columns and right click and hide it. Simply hide. Then both the columns are hidden. Now both the columns are hidden. Now you can see the data, right? So if you want to hide this bed number also, right click and hide it. If you want to unhide, select both the columns and whatever is there in between the hidden column, select on the both end, then unhide. So that then whatever column is hidden, that will reappear. Okay, this is the way we have to hide and unhide the column headings, right? Or the whole variables. Okay. Okay. Hello.
Yes, sir.
Okay, sir. Okay.
Okay.
Yes, sir.
Okay, 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 sir. Yes, sir,
Next
yes,
one is, thank you. So next one is the data validation. So generally in data collection, what we do, we collect the data and we enter it, right? So that is what we do it, and still we have not habituated to collect the data using that mobile app or something. So while entering the data, generally, say for example, this is a flag leaf shape. 1 is pointed, 2 is pointed to rounded, and 3 is rounded, right? So if you just click here in the cell, if you are validating the cell, then you will get the information like this. The first leaf shape of tip is pointed, 1 is pointed, 2 is pointed to round, and 3 is rounded. If you write 1, then it will accept it. If you write 2 also, it will accept. Write 3 also, it will accept. If you write 4, it will not accept it. It will say that please retry. The value does not match the data validation restrictions defined for this particular cell. So if you do so, then you bound to type the correct data. Corrected data in the sense the defined data. Mostly it can be used for all qualitative data, especially for taking dust characterization and all. I think once you just validate this, and then you can collect the data. Okay, so validation can be done. I have validated all these columns. You can see that all these characters are validated. So this is quantitative. So that is the reason I would not validate. We cannot validate that also. Only qualitative data you can just validate it. Okay, you can see this. So how to validate that I am going to tell you. Go to data. Then we have validation here. Okay, simply click on validation. So this cell is already validated. Okay, validated. How to validate? See how many scores or columns or states are there for this particular character. Say for example, this is the panicle attitude in relation to the stem. So 1 is erect, 2 is semi-erect, 3 is horizontal, 4 is drooping, right? So only 4 states are there. That is the reason I have given the 1 to 4. 1 is minimum, 4 is maximum. Okay. So here it represents the whole number. Instead, you can also make a decimal list. You can make a drop list also. You can make a date also. So date range you can give. So apart from those dates, you cannot enter any other date. So also you can make a text length or custom. Even text length also you can assign or validate. If you type more than 10 characters, it will not accept. Something like that. So here we have assigned the whole number, right? So I have given 1 to 4. What is the input message? Input message is this. The title is the panicle attitude in relation to stem. I have just made the title. Okay. So this is the character or variable getting. Then the message input message is 1 is equal to erect, 2 is equal to semi-erect, 3 is equal to horizontal, 4 is equal to drooping. Okay. The whatever way you give here, the same way it appears when you just place the cursor on the cell. Okay, so once you just copy and paste this particular cell to wherever you want to collect that particular data, then all the cell will look like that only. Okay, then error alert. In case if you type 5, then it will give an input error alert. So what kind of error do you want to say? You can make warning or information or stop. Then title also it will come. Then symbol also will come. Okay, so likewise we can make it. So here for your sake, I am just adding one more validation. So 5, I am adding for 5th validation, but it is not there. Others, I am making others. Okay, just say okay. Now you can see that others is added in the data validation. You can see here others is added. Okay, now here you can type 5 also. But if you type, yeah, why this, even if I put 5, it is not accepting because I have not given the whole number properties. See, again, validation. In the settings, here I have given only minimum maximum values only 4. So here I will change 5 and say okay. Now you type 5, it will accept it. Okay, so that is how we need to validate each, sir. Hello. Okay, so that is how we need to validate the cells. Okay, so this is all about the data validation. I think the replicated data arrangement is there. One more option. Then base calculation is there. I think replication data arrangement, should I tell or no need? How many are there? Let me see. Otherwise, am I speaking alone? No, I have 53 people.
No, no, sir.
Sir, we are all here, sir.
Hearing, we are there. We are here.
Good, good. We are there, sir. Good to see you.
All are there, sir.
Okay. So should I continue with 2 more options are available? One is how to arrange that replicated data. Another one is a base calculation, based to 50% calculation.
Yes, sir.
Okay, right. If you are ready, I am also ready. So here it is. Okay, so could you see that Excel sheet, isn't it? You can see the Excel sheet now. Excel sheet is there? Visible?
Yes.
Okay, okay. So
Yes,
here
sir.
I have the data of number of basal tillers. Okay, I have collected number of basal tillers from 3 plants. This is the first plant data and second plant data and third plant data, right? So some software will accept if we just make the data on the row order, right? First plant, second plant, and third plant. But most of the software will accept your data for analysis only on the column wise, right? Was first plant, second plant, third plant. Okay. So how to arrange the data? You have to, how to arrange data means you have to cut and again paste it in a reverse order, transpose order. If that way, if you do it, it will take a hell of time. Okay, you cannot complete your task in time, right? For that, we have found a small formula. Maybe myself and Dr. Avinash, when we were sitting here, so we tried this formula and we succeeded, right? So this one, what I'm going to make it. So this is the first replication data, insert, and this is the first replication data, R1. Okay, and this is the second replication data, insert, R2. Sorry, R2. So along with this, I am adding this MGP number also because I want to have MGP number or whatever number you want to add it along with the replicated data, that has to be there. Okay, this is a R2. So similarly, R3. So the next data is R3. Okay. So now what we have to do is, this is a simple calculation. This data I want to have it first, right? So this should come in second, means column wise. And this data should come on third. So this is the replication 3. Right? So then add 3 numbers here, 4, 5, then 6. Okay. So each number is just added, means it's an increment of 3. So double click it, then it will get an increment of 3. Here, similarly, in the second replication, double click, it will get an increment of 3. Third replication, double click, it will get an increment of 3, right? So now what you have to do, this MGP number R1 and this data. Okay, just to copy it. Copy, then open a new sheet. paste it. Okay, this is the first one. And the next one is this second replication data. Copy. So, copy. Yeah. This second replication data I just put just below to the first replication data. Right? This I am removing heading. And then third replication data, just I am copying it. I'm just copying and pasting it down to the second replication. I am removing this. Okay. So now the data is arranged. So now what we can do? Okay. Now all the three replication data which were in row wise, now I have arranged in a column wise. Simply click on this number here. Just select the whole variable. Go to sort it out. Go to smallest to largest. That sort it out. Okay. So now what has happened? Now you can see that the data is arranged. So bar 1, bar 1, bar 1. These three replicated data is arranged in a column wise. Bar 2, bar 2, bar 2. Bar 4, 4, 4. Right? That's it. Same way you have to do it for other variables. Then you can arrange the data according to the software requirement. Is it clear? Some kind of tips or techniques we need to use it while arranging the data. That's it. Is it clear?
First
Yes,
one
sir.
you show me, sir. First one, replication data management.
Yeah, this is okay. You want to check it, recheck it. Very good.
1 to 6, how you
This
have
is the first. Okay, this is the first plant data is 7, and second plant data is 5. Third one is 7. 7, 5, 7. Okay. Now you can see that 7, 5, 7 arranged in the column wise. Okay. Second plant data 4, 5, 4. Maybe you can say something differently. 16th number. Sorry, 9th accession data. Here also 2 are coming. Okay, 9, 6. This I'll take. So 11 bar 11 data is 9, 6, and 1 data is missing in bar 11. Okay, that I will check. You can see 9, 6, and 1 is missing. Arranged in a column wise. Okay, doubt is clear.
Sir, another thing you have to double click and drag, that will multiplication will come, sir.
Yeah. You just 4. Okay. This R1. If you have 4 plant data, then multiplication with 4 numbers, incremental of 4. So here I have only 3, 1, and already 1, 2 is there, and 3 is there, and here number comes 4. That means this will go to first cell, this will go to second cell. Okay, that third point will go to third cell, and fourth cell you will get the second accession's first replication data. So 1 and 4. So double click it, then you will get increment of 3. Okay.
Okay.
Right. So I'll go to the last one. Last one is the days of. How to calculate the 50% flowering date, number of days to 50% flowering. Okay. So for this, we already we have collected the days to 50% date. Okay. So what is the date of sowing? The date of sowing for this particular experiment is 11/06/2021. Again, even Kharif sowing also happened on 11th only. Okay. So this I am copying and then pasting it to throughout the data. paste it. Okay. So now this is my date of sowing, right? This is my paste 50% flowering date. So I want to know how many days it has taken to have 50% flowering. So DFL. Okay, what to do? So we need to just minus from here. The 50% flowering date should be minused from the date of sowing. Okay, simply go to is equal to, that is a formula. Okay, select this cell. Okay, and minus, then select this cell, date of sowing. Is it clear? Is it clear? Hello?
Yeah, okay, sir. Just
Yes,
Select
sir.
paste 50% flowering date actually collected minus with the date of sowing. Okay, then simply enter. You will get the number that is your 50% flowering date or days. Okay, simply double click. You will get all the date. Okay, how simple it is. Otherwise, you will have to have a calendar. Then there you have to write your days to 50% flowering, then date of sowing, then minus it. All those things will happen. Earlier, even I also used to do like that only.
Sir, sometimes in Excel, iPhone, it won't take, no, sir, while feeding.
We can have a different formats. So this format should be uniform. So right click, go to the format cell. In the date format, it should be that both the dates should be in a common format. So we have different formats. Say for example, this is in, say I'm making it in with month name. So this is month name I have put it. Just a double click, it will change it to month name. Here also I'll change it to month name. Double click it, nothing will happen. So that your number of days it will come automatically. Okay. But the date format should be uniform in both the columns, right? The column is days to 50% flowering and column of days to date of sowing. Okay, then only it will come. If the formats are different, I doubt. I have not tried for that. Okay. So with this, I'm closing all my demo on.
Sir, how to do it that regarding standard error bar, box bar in Excel sheet, sir?
Standard error for?
Box standard error graphs, sir.
Which one, sir?
Standard error graphs. Graphs in standard error, showing the standard errors in graphs.
I think that we have to do it in that SAS or R analysis.
Here also in Excel also we can do it, sir.
So we can, unless the data will get it and we can just copy it and paste it in the graph itself. Okay. So the attendance is 48 out of 130. Maybe some are sitting in the rooms. Maybe we have our conference room. I don't know how many are sitting there. Maybe in other places also. If you have any doubt, please ask me. Tool bag is most important. Very nice. It also works.
Sir, how to get data analysis, sir? You have told that data analysis tool, in particularly add-in, we have to go and we have to take it.
Yeah, you go to file and then you have to add in. Go to options, then you have to add in analysis tool. Then say okay, then whenever you click that data tool, then you will get data analysis portals.
Yeah.
Okay.
But sometimes it won't come now, sir.
No, it comes. Which version you are using it?
The 10, sir.
It will be there. Nowadays it is all inbuilt. Otherwise also you can import it, you can download it separately and you can add in also. There is a package called Analyze It, that whenever I open my Excel sheet, that will come. So that always gives me a problem. But I use it, but if I open a new sheet, New. The year it is not coming. I stopped it. Otherwise, it automatically comes. So you can see that analyze it voltage tool. So there you can make all kind of analysis like PCA, correlation, all will come in. Okay. So that is also, we can just download the statistical package from net that you can add into the Excel sheet. That is also possible.
Okay.
Whenever you open that sheet, it automatically comes. Okay, any doubt? 7-9 कैसा चल रहा 2 दिन का ट्रेनिंग? 7-9
No doubt, sir.
Okay, no doubt. Control Alt delete.
Okay, sir.
Okay. What about others? If you have doubt, you can just put it in the chat box, and tomorrow also we have full day. And tomorrow we are going to have classes by
The correlation, okay, sir. How we do correlation?
all can be done using that data analysis. All are possible there.
That one I need, sir.
You want it? Okay, let me try. Close down. Okay, this is data.
Yes,
right?
sir.
Data is visible.
Visible, sir. Visible.
Okay, simply go to data, then data analysis, then go to correlation. Say okay.
Okay.
Now we have to give the input range. Then select that input values, including the title.
Right.
Okay. So I have selected the complete data. Right. So now the first labels in first column. Okay. I'm going to analyze on column wise, variable wise. Okay. The output range I am going to put it in the same sheet. Okay. So I have to designate the area where the data should be coming. So I'm just placing my cursor here in the empty cell where data will be appearing. So simply press OK.
Okay, sir.
That's it.
Okay, I understood.
Right? Very simple. Simply reduce that column, this thing. Then sorry.
Sir, stars how we will get, sir?
Stars, I think it is there. It must come.
Okay, sir.
There, I think that option I have not selected maybe.
Okay.
There we can see it. Okay. Less
Okay,
than
sir.
5.
I understood.
And maybe, yeah, some values are see 0.81 positively correlated. So something flowering date and maturity is correlated. Maybe negatively or positively we have to see it. Okay. So this is the way we have to make it. Everything is possible. Only thing is we need to play with that. You play before work.
Work, sir. Sure, sir.
Okay.
Sure.
Okay. Any doubt? Any more doubt? Or else shall we close it today and we will have it tomorrow. 11 o'clock tomorrow class starts. We will start with field book demo. Sir, namaste sir. Sir, vanakkam sir. So நீங்கள் இருக்கீங்களா சார்? நான் NS யார் இருக்காங்கன்னு தெரியல. கேட்கலாம்னு நினைச்சேன். Thank you sir. Thank you. So we have our MPPG, our partner also there. All are attending. Thank you so much sir for attending and supporting us. So otherwise, sir, tomorrow also 11 o'clock we are going to start the class. Maybe all your students can attend it. Morning 11 o'clock we'll have. Sir, you please unmute, sir.
Oh, good evening.
Good evening, sir. Good evening.
Tomorrow morning, some medical students are visiting. I have to take some lecture on morning. It's not possible.
Okay.
But other
students, if you can tell them.
You have.
Morning 11 o'clock we will be having a demo on field book.
Okay.
And afternoon classes are regular, sir.
Yeah, that's good.
Okay. Thank you so much.
Congratulations.
Thank you, sir. Thank you, sir.
Sir, Elangovan, sir.
Who is this?
Sir, this is Chandramohan Reddy from.
Yeah, Chandramohan. చెప్పండి.
Sir, actually, I was so puzzled regarding the replication, traits replicated data to an analytical conversion. So, Brahma Vidyanu, Kusu Vidyaga, just very simply, just that conversion, really, I was very much
అంతే
impressed.
సార్, మీకు మనం ఉంటే మార్గం ఉంటుంది సార్.
Sir, yes,
మనం
sir.
ఉంటే మార్గం ఉంటుంది.
Yes, sir. Yes, sir. So I was having in my mind regarding to ask that question. So before asking, clarified, sir. I was so
because
so
I can read your mind,
satisfied. Yes, truly, sir. Truly. Thank you so much, sir.
Thank you so much, and let us meet tomorrow. Okay.
Yes, sir. Yes.
See you. Bye.
Thank you, sir. Nice demo. Thank you.
Ramana garu.
Yes, sir. Yes, sir.
Okay. Thank you all. Ramana, you can.
Thank you, sir. Thank you very much.
Thank you, sir.
Meeting.
Oh, nice presentation, sir. Thank you.
Thank you so much.
Elangon sir, మీరు క్లోజ్ చేస్తే మీటింగ్.
అవునా, ఓకే. సో రేపు మార్నింగ్ 11 o'clock మళ్ళీ.
ఓకే సార్.
థ్యాంక్ యూ